All right. Hello, everyone. Can you hear me okay? Well, so nice to see everyone. Thank you for joining us for this, the last in a series of seminars that CS50 has been holding since the start of the new year. The very first one was on Python. The very next one was on SQL. More recently, we've had one on Linux, and now we have our seminar on game development. You'll find that this seminar might require a little more comfort with computing than some of the past ones, insofar as you'll need ultimately, either during the seminar or after the seminar at your own pace, to have some certain software installed so that you can actually create and run these games on your own computer. Not to worry if you haven't installed anything yet, not to worry if you can't follow along hands-on during the seminar itself. Everything's going to be freely available on the course's website afterward, including the video, all of the source code, all of the slides, so you can certainly walk through at your own pace. We're joined today too by some of CS50's wonderful mentors who have been volunteering their time over the past several weeks to answer questions here in the Zoom chat, as well as on ED, the course's discussion forum. So indeed, if you have any questions today, please feel free to ask via the chat, and either they or the staff or our special guest, our teacher today, will do our best to field them collectively, but continue to ask questions in the coming days via ED as well. So we are so pleased to begin today with a little tradition of ours, which is to take a group photo of sorts. If you would like to opt into this, please feel free to go ahead and turn on your camera now. And in just a moment, we'll invite everyone to put on your best smile and perhaps a wave. And our colleagues behind the scene are going to start flipping through all of the pages of tiles of all of us here around the world. Over 180 of us now in the room all together, from India, from Canada, from Poland, from Georgia. Let's see, keep scrolling up in the chat, up and up and up, Indonesia, New York, and beyond. So nice to have indeed so many folks from around the world. Rongshin, how are we with the photos?
I think we are all set. Thank you.
All right, we'll be sure to post a big mosaic on the course's website after this. So pleased to introduce indeed today's special guest, CS50's own Colton Ogden, who worked with us in Cambridge for so many years and also went on to teach his own course here at Harvard on Introduction to Game Development. Indeed, this course is available freely as open courseware as well as via edX. So if you like the taste of game development that you'll get today on how you can write games on your own Mac or PC or device, know that you can dive even more deeply into this world of game development and spend all the more time with Colton in the class via that free one there. And we'll post the URL to that in the chat in just a bit. So Colton, without further ado, welcome back.
Awesome. Thanks so much, David. Appreciate it. And hello, everybody. Thanks for coming to this seminar. Like David said, this sort of topic of game development can be a little bit more requisite of some prior programming knowledge. But we're going to do our best today to make sure that things are as gentle as possible. We've got some mentors and other folks who are going to post links to some resources in the chat who can help with the setup process, as well as to get in touch with my slide deck that I'll be using today, and the code repo that we'll be adding to, and also that we've already submitted code to, in case you want to download the code in advance to see what it'll be like going through the rest of the seminar here. I'm going to go ahead and make sure that I have my screen shared before we begin. So now you guys should all be able to see my slide deck there, the beginning of the slide deck anyway. And there should be a link in the chat with that as well. I'm going to also make sure that I have access to the chat here so I can see what's happening. And I know that there are going to be mentors actively answering questions, and folks like Valerie are going to be looking at the chat and asking me questions in case I missed something. But yeah, do feel free to ask questions as we go along if you're stuck, and we'll do our best to accommodate. So without further ado, this is pre-CS50 Games Edition, and my name is Colton Ogden. I teach GD50, which is CS50's sort of offshoot game development course. We go into a lot more detail and a lot more games than, say, Pong. We cover, for example, Mario, Legend of Zelda, a lot of really classic titles, in addition to some games that are a little bit more recent, like Portal, using Unity. But for the first 2/3 of the course or so, we use a couple of technologies, primarily Lua and Love 2D, which we'll be using today to illustrate how to create Pong. And this is going to be our goal today. By the end, we'll have something that looks something very similar to this. This is actually what's in the repo currently that I have contributed to that we'll be posting in the chat. And you can see it's pre-50 Pong. It's a very classic game. If you're unfamiliar, Pong is a game where you have two paddles on the left and the right side of the screen. The goal is, of course, to hit the ball towards the enemy paddle and make sure that they don't hit it back to you. In other words, make sure it goes past the left or the right edge of the screen. And when you do that, you gain a point shown there in the middle of the screen. And the first to 10 points by default is the winner of the game. Very simple game, but it was one of the most popular early arcade games back in the 70s. And today, in order to build Pong, or a sort of a crude version thereof, we will, as I said previously, be using two technologies. And those are Lua, which is a programming language, and then Love 2D, which is a framework, which is sort of a set of tools, or a set of almost like a box of Legos with which you can build a game with, things that give you access to sound, to drawing graphics, to drawing shapes, to detecting user input, to doing all kinds of different things. And we'll be covering a lot of those in a very simple terms today with the usage of Pong, the illustration of Pong. Now, there are a couple of steps involved in actually getting set up. We won't spend a tremendous amount of detail just because there are resources already available and links that will be posted describing the setup process for your operating system, whether you're on Windows or Mac. You can also get the setup on Linux as well, although it's a little bit less, I think, straightforward than the Windows and Mac installation process. But the key is that you're going to want to download the Love distribution for your operating system from Love2D, which you can just go to love2d.org, this URL here. And in addition to that, there's a very nice set of instructions for getting started, and also digging into the beginning of how to use the framework through the wiki page there. So I'm going to go to my browser here, which I'm already in actually, and just show you that. And I have a plugin here that's automatically turning off my tabs, so apologies for that. But this is love2d.org, which is the homepage for where you can download the framework Love. You can see there are distributions for Windows Vista Plus, Mac OS. They do have Linux distributions, and they have older downloads as well. For example, Android and iOS. And in particular, the most recent version is 11.3. So back to the slide deck here. Oh, and actually, I did intend to show the and I got the Zoom thing here, kind of blocking my my view here. Let me just go ahead and kind of expand this out here a little bit. Apologies for that. The actual wiki here, you can see the love2d.org/wiki/main page kind of goes through a lot of interesting resources here, in particular getting started. So I'm going to go ahead and post this link in the chat so that folks can follow along. In case you want to read up on the basics of how to get started and how to do some pretty easy early programs. You can see, for example, here there's a Hello World program that it shows you how to type out. That was sort of included in the instructions for setting up on Windows and Mac, and it's a nice way to just verify that your system has been set up with Love2D. Let me go back to slide deck here. Before we actually, I think, dive into the technical details, how to actually code everything, I kind of wanted to talk briefly about what a game is. And I think a very simple illustration of what a game is, at least in my mind, is kind of like a flip book. But it's basically a set of a bunch of almost like sticky notes kind of in one little bundle that you would rapidly flip through, right? And each page of the flip book has a different picture on it. And you change the picture over the course of time, and that ends up leading to sort of an illusion of an animation taking place. And games are kind of similar in that they are like a flip book, in that you are drawing something different to the screen over and over and over again. And I mean, this is like how TV works, how basically anything with a screen works. But games are different in that you're actually kind of drawing the flip book as you go and kind of dynamically doing it. And that's going to give you the appearance of kind of watching something, watching a movie, or in the case of Pong, a movie is kind of a generous description, but you're sort of watching something take place dynamically. It's changing, there are things happening, and there are also sounds and other things happening as well. So it's a little bit more dynamic than maybe a flip book in and of itself. But that's kind of like at a conceptual level, what a game is a set of pictures that you're drawing and changing in real time. And obviously a lot more than just a flip book number of pages. You're really talking about 60 frames a second typically, which add that over the course of hours. You're dealing with hundreds of thousands, millions of frames. So a bit of an ordeal certainly, but for a computer it's very easy to do this. And additionally, there are other facets to this that we'll talk about in more detail here in just a little bit. But before we talk about, I think a little bit more, I think I'd like to open up the my text editor here and maybe get started actually writing some code. And if there are any maybe any questions that seem germane so far to what we've talked about before we dive in, we can maybe answer some of those, unless the mentors have been keeping on top of things. Do we need a painter or graphic designer to create a game? No, actually, you do not. And I'm a perfect illustration of that because I am neither of those things. Thankfully, there are a lot of great tools these days for folks who aren't super familiar with drawing or comfy with drawing. I, for example, use a tool called Sprite. This is a sort of minor detour, I suppose, but Sprite is a really cool sprite editor and pixel art tool that I like to use. But you can use a lot of different things. You can use GIMP, you can use Photoshop, you can even use Microsoft Paint if you want to. It's not my personal recommendation, but it's a choice that you have. But essentially, as long as you're able to draw onto a pixel art editor like this and save your art to a PNG or a equivalent file format, you can absolutely create games without a lot of expertise. Whether your games will look fantastic, that's a different topic, but you certainly can do it at a technical level. Absolutely. Props to anybody who can make a game with MS Paint. Okay, so VS Code is the text editor that I like to use. So if unfamiliar, VS Code is a sort of lighter implementation of Microsoft's Visual Studio, which is an IDE, integrated development environment that Microsoft has released for a very long time. VS Code is open source and really super nice to use. It has a lot of cool features. It has a built-in extension lookup. It has a lot of really cool default linting and debugging capabilities. And I put a link there in the chat that you can use to download VS Code. Now, of course, you can use a lot of different editors. You can use things like Atom. You can use technically you can use really anything. But the more features your text editor has, the more sort of comfort and I guess readability and accessibility you'll have, and productivity therefore you'll have in writing your application. What makes VS an IDE over VS Code? A lot of like built-in profiling stuff. There's a lot of crazy stuff that Visual Studio has. It's a massive application. VS Code is arguably in some aspects an IDE in that it does have some debugging built in, and that's sort of, some people might consider that to be an IDE feature over a text editor feature. It's certainly kind of a gray area whether VS Code's an IDE versus a text editor. I consider it kind of a hybrid, but Visual Studio, the regular Visual Studio, is definitely fully fledged, very robust, very large IDE. Should we have learned Lua before starting the seminar? It's not 100% requisite. We'll be covering some of the basics. I would encourage you to do so. In fact, that actually lets me segue nicely into the fact that I have this tab here for folks who want to study up on the basics of Lua before diving into Love2D. That's the Lua 5.3 reference manual. So that's one of the more recent versions. I think that's the most recent version of Lua. Not 100% positive on that, but this has basically all of the information you will need in order to be well versed enough in Lua to be productive, or to be comfortable, I should say, in Love2D. You don't need to know everything that's inside Lua, because Lua it's got a pretty large set of internal functions and libraries. But at least as far as the basic concepts, how to use variables and functions and stuff that we'll talk about, this is a great reference for that. And just even Googling a lot of things about Lua as you're using it and running into your own obstacles, you'll find that the Lua reference manual gets referenced a lot online. So it's a good resource. Good question though. So this is, once you've downloaded and installed VS Code, you should have a window that looks very similar to this. I have already opened up a folder that I'm going to be using for the seminar that has the code in it from before, in case I need it as a crutch. Hopefully won't need it as a crutch, but this is what you'll see if you download the GitHub repo. There's the main.lua and push.lua. So we'll talk about what push is a little bit later, but main.lua is the one file that basically is going to encompass the code of our game. I'm going to be writing code into a folder called live. And so just to illustrate, on my computer, I have a game dev folder. I've created a Pong seminar folder in here. Within this Pong seminar folder, you'll, if you create it, or if you download it off of GitHub, you'll see something that looks very similar to this, with a .git folder. If you can see hidden files, a live folder, which is going to be where I write code right now, because we're doing this live, and then a pre-folder where I have the code that I wrote and contributed to GitHub in advance. So again, we're just writing only to live today. In Love2D, basically what you need to have to actually start working with Love2D, to run it, you need a main.lua file. And if you've coded in C before, or even Python, you might have seen this name, this word main, or this reference to main. Basically, main is just like a starting point of an application, especially in C and C++. That's and even in Java, this is something that you're going to see as a starting point. And Love2D is no different. It expects a main.lua file. So we're going to go ahead. I'm going to just right click, do a new file into this live folder. You can also do Control N. And I'm going to just type main.lua and save it. And you can see now it's opened up on my screen here. I got main.lua. And additionally, if you're using VS Code, and this is in the instructions that we've posted with the seminar information, or the Love2D setup information, you can actually download an extension. So on the left side of VS Code here, there's an extensions menu. I have a Love2D support by Pixelbyte Studios extension installed. And this is super nice because what this lets us do is, if you've installed it on Windows using the default installer, you can just hit Alt-L. If you're on Mac and you follow the instructions listed in the setup instructions, you can do Command-L. And basically, instead of having to, for example, by default, you can click and drag your folder onto Love2D, and that'll open up your project. You can just hit Alt-L or Command-L within the text editor. So for example, I'm just going to quickly say function love.load, and we'll explain what this all means in just a second. Love.graphics.print hello world, like so. And if I hit Alt-L, we can see nothing on the screen there. So let me go ahead and make sure that I'm actually selecting the correct folder here. Oh, sorry, I did that in load. This needs to be in love.draw, not love.load. My apologies. We'll explain what that all means in just a second. Now, if I do that, you can see that we have hello world shown here on this window right here. I didn't have to click and drag the folder for Pong Seminar onto Love2D, which would be what you would need to do sort of ordinarily if you're using it like most applications. Using this extension, the Pixelbyte Studios, you can just quickly hit a shortcut, a hotkey shortcut to open it up in VS Code. So this is one of the big reasons why I like using VS Code. I mean, I like using VS Code ordinarily for most things, but why I particularly like using it for Love2D development is that I can have a quick, easy access to doing that. How to use this extension on Mac, asks Sarah. We have instructions posted. If anybody doesn't mind sending the instructions there in the chat, there's a link that we posted that has all of these setup instructions. The Mac instructions are listed in there. It's very similar. You download the app for Mac, you put it in your applications folder, and then you go into the extension settings here, and then you make sure that the field for the path, if you go to extension settings, there's a path here. You just make sure that this represents where you have it installed on your file system. And then additionally for Mac, there's a little bit of extra thing you have to put here after the love.app part. Let me just make sure I haven't missed any pressing questions. Faria, do make sure that you have installed it and not downloaded the zip. Sometimes that'll cause the issue. Alt is usually option, control is usually command. So yeah, but on Mac, particularly for this, it expects, at least on the machine that I tested on, the Mac machine that I tested on, it needed a Command L, unless things have changed in the very recent past. Okay, looks like things are all together going okay. And if anyone's caught up on any technical details, if things don't work, do post an ed, and also maybe post in the chat, and maybe a mentor can assist. And then ultimately, this isn't supposed to necessarily be a super technical seminar, more to illustrate things. And we definitely will be posting the videos and the code and whatnot online so that folks can follow along later if they are running into any stumbling blocks currently. But do post an ed, do post in chat if you are experiencing any issues. But this is sort of the beginning of how you you run a Love2D project. Make sure you have main.lua. Make sure ideally you have the VS Code or extension set up working. If not, if you can't get this working, depending on maybe your machine, you can always take the folder with your main.lua. It has to be the folder with the main.lua, and click and drag that onto the love.exe or the love executable on your machine, and that will alternatively run the game. All right, awesome. So that's the sort of probably the most technical side of what we're going to be doing today in terms of setup. So if you can at least get it running on your machine, whether it's by using the extension, whether it's by clicking and dragging it onto Love2D, you'll be able to follow along from here on out. Let's go back to the slide deck here and talk about something for just a second before we start writing a bunch of code. So previously I talked about what a game is sort of in a very abstract sense, putting it in terms of something that's very, very simple, very more real lifey. But this is a slightly more technical representation of what a game actually is. A game is ultimately at its core a set of steps, and it's repeating these steps infinitely over and over and over again. If you've taken programming courses or CS50 in the past, you probably are under the impression that an infinite loop in most cases is bad, and it's a bug, and it should not exist. And this is true for a lot of things, but there are a lot of things that are infinite loops that should exist, that are actually beneficial to exist in that form. For example, rendering anything on the screen, or a web browser refreshing the contents of the page and displaying it to you. These are examples of infinite loops. Or for example, a web server listening to requests and sending back responses to people online, all day in and day out. These are infinite loops that are good. Games are infinite loops that are good because they just by virtue of the fact that they are always on forever, waiting for you to input, and sort of run into enemies or do whatever, until you turn the game off explicitly by using some piece of hardware or a software switch. These run in an infinite loop forever. And you can see that they're a pretty simple set of steps here in this, maybe perhaps an oversimplification of the game, what a game loop is. And this is a game loop, the terminology would be appropriate. You have a set of steps here. So process input, update game, and render. So these things happen sequentially, basically every 1/60th of a second, in a span of 16, 17 milliseconds. You have input processing, which means, check to see whether the user has typed a key or, touched their control stick or, done a whole bunch of other possible input mechanisms, depending on what game engine, what platform you're using. And then once they've entered the input and once you've processed it, then you want to update your game. And this can happen multiple times, as shown by this loop here, depending on how much time has passed since the last frame. We won't get into the technical details of that necessarily, but you can ignore this, but know that perhaps it happens maybe multiple times per frame. The game gets updated, meaning that things on the screen change their positions. Your paddles change positions, your characters change positions, something changes color. Imagination run wild with that. There's, any game can have infinite possibilities, right? And then lastly, once things are updated, you render everything to the screen. And that just means drawing it onto the screen. So you have everything, you have your characters, your paddles, whatever your game engine, your game consists of, those all have various attributes, positions and colors and all sorts of different things. Those all are basically values in memory stored on the computer, but then they actually need to get drawn to the screen. And that's what happens during the render phase. The updating takes place sort of invisibly in memory, but the rendering is what lets you see what's happened, translates that to a visual representation. And that's essentially the gist of what a game loop is. And Love, fortunately, Love2D represents this perfectly in a set of functions that we are now going to write to better see what happens to the, to better see how we can translate this game loop idea into practice. Let me just make sure that I'm caught up here on the chat. Love.graphics.draw, what does that do? Love.graphics.draw draws sprites to the screen. So we're not covering sprites today, we're just be drawing shapes to the screen. But love.graphics.draw lets you take a picture or an image on your computer and draw that to the screen. So you can have sprites, you can have any artwork that you've drawn or that you've taken from somebody else, alluding to what we talked about sort of previously with Sprite and Microsoft Paint and those sorts of tools. You can import that into your app and use love.graphics to draw that onto the screen in a particular place to simulate sort of the flipbook aspect of moving that picture around, or maybe even changing its animation. What language is used for the backend purpose? In this case, we're not doing any backend programming. This is all front-end stuff, but you can use backend. Unless you're referring to how does the Love2D framework work behind the scenes, that would be C++. That gets compiled into a executable that you can then reference using Lua. Lua is a dynamic language that you basically tie into the basically you write everything in a more low-level language like C++. It's got a bit more nuance to it. You have to do memory management, things that are a lot more low-level. You compile that into a program, Love2D, which then you say, I will allow a higher level language, something that's simpler like Lua, to be able to interface with it, which can then call those functions that I've compiled down into optimized machine code, but without having to write that C++ code that can be a little bit more rigorous to write. If that was the question that you were asking. So hopefully I answered the correct question. Why would you want to have multiple updates per frame? Isn't your FPS your max speed of displaying something? There are some instances where you might drop a frame or two. And in that case, you're going to want to update the difference between those two frames, basically. Because if you drop 2 frames or 3 frames or 10 frames, but you don't update what's happened between then, you'll basically freeze time for that span of time, rather than have things sort of move the same amount of time since that last basically that last rendering took place. This is a topic that we touch upon a little bit more in GD50, and it's something we'll talk about a little bit as we get into updating. But essentially, you don't necessarily have to update more than one time each frame, but that's typically how you want things to behave if you want your games to behave the same and move the same on different platforms, if that makes sense, at a high level, at a basic level. Okay, so we're going to go ahead and forge ahead now with a little bit of code. We've been kind of going a little bit more in the conceptual direction, but now it's time to talk about how the game loop sort of translates into Love2D. So we've already written this love.draw function here, and I didn't really explain what we were doing. So in Lua, function just means that this is a block of code that can execute some behavior, and it sort of gets encapsulated, and then we can reference it or call it later. In Love, it expects a set of functions to exist in your main.lua in order to work properly. In this case, love.draw is the equivalent of this render block here. This render box is love.draw. That's how we can effectively think of it for the sake of this seminar. There are other pieces of that puzzle. For example, love.update, which takes in a parameter called dt. And what basically this means is that love.update can also take an input. So it expects an input called dt, which is short for delta time, which is an amount of time in seconds since the last frame, effectively. And this is basically what we can use to interpolate movement. We won't talk about this too much right now. We'll get into this a little bit later. But essentially, this allows us to make sure that things move the same distance over the same span of time, whether we're using a slow computer or a fast computer. It's basically to make everything consistent across machines. And this love.update is the equivalent of this update game box right here. So all of the logic that would go into making sure that everything in our game updates should ideally go into this love.update function, if that makes sense. And then lastly, there's a love.keyPressed that takes in a key as a parameter. And these are all functions that Love expects that are hardwired, basically. We're not creating, or making these up from scratch, basically. Love.update, love.keyPressed, love.draw. These are things that the Love2D framework expects to exist in this main.lua file and will behave according to how we have manipulated or wired the behavior of these functions. This love.keyPressed function is, as you could have probably guessed, the analog of this process input box right here. Now, the beautiful thing is that we don't actually have to maintain this infinite loop ourselves. We don't have to create if you're familiar with C or CS50, you'd see a while true, do some amount of, or while, something is equal to something, do some bit of code over and over again. Love2D takes care of all of that for us. We don't actually have to do that. As long as we have these functions in here, love.update, love.keypress, love.draw, and there are a few other functions, for example, love.load, which I wrote earlier, love.load. This is another function that love expects to exist. Optionally, these don't all have to be included in. As you saw earlier, for example, I just wrote love.draw and I didn't have love.keypressed or love.update or love.load. It doesn't have to have those functions. It'll give you default versions of those functions. But if you have written these functions in main.lua, it will take the behavior that you've coded in there and it will apply it to love2D so that it behaves how you've programmed it effectively. Just making sure that I'm not missing any super pressing questions here. Looks like mentors are keeping on top of things. So appreciate the mentors.
We have someone ask a question. How would you rate comments?
Oh, sure. So it looks like it looked like Aditya had gotten to that, but comments are as simple as double dash. So as long as you write a double dash right there, I can type all of this, and that's completely ignored by Lua, by Love2D and Lua. So super useful to know. Optionally, you can also do, if you want block comments, you can do something like that where you have double dash and then double hard bracket left. And then that will end up being a block comment, so that you can actually write a bunch of comments. I can do this, I can do it on a new line, and that's the equivalent, for example, /* in C or Java /*. So good question. Let me make sure I'm scrolled all the way down to the bottom of the chat here. So someone was saying, how would you run the code in Love? You basically just drag, if you're not using VS Code, you drag the folder with your main.lua onto your Love executable, or if you set up the VS Code extension that I showed earlier, you would do Alt-L like so, and then that will show you you can see the window that I have here, the Love2D window, and its default size and resolution. So now that we have talked about sort of how the game loop translates into Love2D, we're going to do a little bit of coding here to actually get a very basic version of the window up and running, so that we have more than just a simple black box. I'm going to keep these functions up here blank until I need to write code into them. One of the things that I really like to do when I'm coding games, and this is something that's kind of a personal touch of mine, it's not necessarily strictly necessary, but I like to use a library called Push, and this is on GitHub. This is a very simple sort of virtual sort of resolution simulation library, I guess. It basically lets you take a window and print into it or display into it any resolution that you want, so that we can get sort of old school looking graphics without too much trouble. This can be kind of a pain to get working properly if you're not using a library like this. So this is a link to the library. All you have to do is download that. You can either download the zip or you can clone it if you're using Git, and copy that over into your folder, whatever you're using. I should say, copy the push.lua file that's in that directory over into your folder. So I'm going to take it from the pre folder in the seminar distro. I'm going to just take that and drop it right here into live. You'll see that reflected in my VS Code here. You can see I have this push.lua right here, and there's a bunch of code in here. It's all Lua code, or rather Lua and Love2D code. And we're not going to cover any of the technical details as to how this works. Essentially, it's drawing to a picture and then stretching that to fit the window that we have decided to allocate. But what this is going to let us do, you can see, for example, if I resave and then reload this, the text on the screen here is super tiny, this hello world, because it's rendering it at effectively native resolution by default, a font size 16, I believe, or font 14. And I personally, when I'm making games that are kind of an old retro flavor, kind of akin to something that you would see with like Super Nintendo or older even. For example, here you can see how pixelated and close up looking it is. It's nice and crisp. It doesn't have sort of I don't know how to describe it other than maybe crude look to it. So to get around that, what I'll do is I'll draw as if I was coding for an older game system, like a Super Nintendo or an NES. So what I'll do is I will create a couple of variables here at the top of the file. I'll create a virtual width. I'm going to set that to 384, and a virtual height, which I'm going to set to 216. And I believe these are the right attributes. I'm pretty sure they are. This is effectively an old 16:9 style resolution. 16:9 meaning the ratio of the width to the height of your screen. 1920 by 1080, 1280 by 720. These are other 16:9 resolutions. We're going to be using 1280 by 720 because I'm using Windows artificial scaling. If I use 1080p, it'll go full screen. I don't want that. But you can set this to whatever you effectively want, because this isn't really going to matter. But I'm going to set a window width to 1280 and a window height to 720. And these are two different pairs of values that are both going to be super useful. So these are variables, just like you would see in C or Python. Lua is a little bit more similar to maybe Python and also JavaScript. For example, if you're coming from C, you'll notice that there aren't any semicolons needed. You'll have noticed that down here on line 19 on my end, there wasn't a semicolon needed. And you can also use single quotes for strings, for example. These are features that Python and JavaScript use a lot, but something like C or C++ is a little stricter in that you would need semicolons, you would need double quotes for strings. Additionally, I'm going to say push equals require push, and push is a string in this case. And what this is going to do is this is going to use a variable, and it's going to require basically import the logic that's in this push.lua file. By default, if you don't specify a file extension on a require string here, it's going to basically do the equivalent of push.lua. JavaScript does this a lot too with modern sort of JavaScript ecosystem stuff. So if you're coming from a web background, this will probably feel very familiar to you. But basically, we're going to say push equals require push. That lets us load the logic of the push.lua file that we just downloaded into a variable called push. And what push is going to let us do is say push setup screen, which is a function. So notice that I've used a colon here. This is how you use functions that belong typically to libraries or things called classes. We won't go into detail with that. But if you see this colon, know that that just means that it probably belongs to a library or to a class or to a function that has a bunch of values embedded within it. And we're going to say virtual width, virtual height, window width, and window height. We're going to pass in those 4 values that we defined up here into push setup screen. We're going to go down to our love.draw, and before the love.graphics.print function that we called previously, we're going to say push colon start. Again, another function that belongs to push. And then after it, we're going to say push colon finish. And these two functions together are sort of like what encapsulates what we want to draw to our virtual screen, our virtual resolution that we've just defined. Now, assuming that I have written this correctly, if I now run this code, you can see that we have a different aspect ratio to begin with. We have it's 16:9 instead of a square or more squared, and our text is way bigger at this top left because we're actually drawing to a canvas effectively that's 384 by 216 pixels getting mapped onto a window that's 1280 by 720 pixels. So we can make this window whatever size we want, but it's always going to draw to this 384 by 216 resolution. So no matter what window size we have, how much we resize it, it'll always look as if we're, for example, drawing to an old console game or something, an old arcade game, an old resolution. And when I'm developing, this is kind of what I like to do if I'm doing old 2D pixel stuff, because I think it just looks a little bit better personally. Let me make sure that I'm caught up here on a couple of questions. Javi says no main function needed. That's an excellent point. We don't need any sort of main function in Love2D. It doesn't expect a main function. The analog to that, which is necessary, is that this main.lua exists that has these functions that we've listed in here. That's effectively the equivalent of the main function from C or from Java or from C++. I'm just reading some of these comments here. And if anybody, again, is having any technical issues, if anybody could post the reference to how to run the stuff on the various operating systems, Windows and Mac. Alternatively, do go to the Love 2D wiki, which has the instructions on how to install it for your computer. It's relatively straightforward to follow. Typically, you'll download the app, you'll take your folder with your main.lua, you'll drag it onto the folder, or if you're using VS Code with the extension that we've talked about previously, you'll run that using the shortcut that I've talked about previously. But that is effectively how we get to the running things in a window that's the right aspect ratio at the virtual resolution, so that things will look decent the way that we want them to look. Now, that being said, there are a couple of things that we're going to be running into that that you've probably seen as a result of that. So for example, if we rerun this, you'll notice that this text is at least maybe easy enough for it not to see on your end. If you're looking at my screen, it's really blurry. And if you're running this on your screen, it'll look really blurry as well. And this is because by default, Love 2D actually does what's called texture filtering on fonts and images. And what this basically means is that when it upscales or downscales a texture or a font, it will basically fill in details around edges of those fonts or images to make them look smooth. And if you're using high-res art and you're upscaling or downscaling it, this can be good. It can be a good thing. It'll look nicer. But for us, we don't actually want this to be the case. So we're going to say love.graphics type set default filter nearest and nearest. So this is a function in the graphics module. And as an aside, when I said before that Love is sort of a box of Legos with all these features, Love.graphics is kind of like one of those boxes of Legos. It has a bunch of different functions within it that let us do various things. Love.graphics.print is one that we've used so far. It lets us print text to the screen. Love.graphics.set default filter, that's another Lego. It lets us change how things are filtered on the screen. So in this case, by passing in these two strings, nearest and nearest, we've set the filtering to what's called nearest neighbor interpolation, which basically just means that it's not going to fill in any pixels that don't exist already. It's going to take in whatever the equivalent would be if it were to zoom in and take a pixel point, an XY point. We don't need to worry about the technical details of that. But the result of that is that when we run this, it ends up looking exactly as it would if you were to zoom in and say Microsoft Paint or GIMP or whatever at the raw image data. It's the pixels on the screen that you would expect if you had written this or drawn this yourself. So it looks a lot blockier, it looks a lot crisper, at least on my end, and it should look the same for you. And nearest neighbor interpolation, nearest is typically what you're going to want when you're doing low res sort of magnified development. All right. Make sure these are working. If folks are running into syntax errors, probably won't be able to spend too much time addressing those, but do post the issues you're having in the ed discussion groups. Alternatively, the mentors may be available to assist, but we probably won't be taking time out of the seminar to address those types of issues. But conceptual questions and questions of that nature, we probably will have time for. But yeah, that is effectively how we get the text, the virtual resolution, and going forward, everything effectively looking nice on the screen. So that was all of that stuff. All right. Download the push.lua, extract it in the folder. Yeah, so now you can do, as said before, just the push equals require push, and then follow the code that we've talked about so far. And if you want to catch up, we do have all of the code in a repo on GitHub that folks have posted in the chat. If folks could repost that possibly in the chat, you can download the code and follow along or catch up or even maybe get ahead if you want to some of the stuff we'll be talking about in the seminar. So we've been going a little bit slow just to get things off the ground, but now I think I want to start getting into a little bit more of what is relevant to Pong. And that's if we go back to our image here, let me make sure this is in present mode here. Come back to this illustration, we can see that we have a few things on the screen. And if you've been following along, you're probably already able to recognize maybe some of the stuff and maybe some of the ways we can get that on the screen. For example, this pre-50 Pong bit of text here is just love.graphics.print, but with a bigger font. These are also the same, these numbers, this press enter. You can see that we have these paddles here on the left and the right, and this ball here in the center. And I think the best place to probably start might be to get these paddles drawn onto the screen, just because that's a little bit more, I guess, fun. And we've already been talking about text for a while here. So typically, what I like to do is represent everything in the game, all the things that could move around and do things as a bundle of data. And what we're going to want to do is, first of all, before we do that, why don't we just do something really simple and replace this love.graphics.print function with a love.graphics.rectangle function. Now, love.graphics.rectangle does exactly what you might expect. It draws a rectangle to the screen, and you can see here, because I have the Pixelbyte plugin installed, it tells me what parameters it expects by default. It expects a mode, an X and a Y, a width and a height. And if you were to want to explore some of these topics on your own time and maybe understand a little bit more in detail some of the boxes of Lego, so to speak, in other words, the namespaces, the function lists that are in Love2D. On the left-hand side here, if you're on the wiki, you can actually see love.audio, love.graphics is here, love.font. If you go to love.graphics, for example, apologies if it's kind of small on your end, but we go down here to love.graphics.rectangle, you can see that we can click on it, and it shows us all the different ways that we can use this function, and it describes all the parameters that it takes in as well. And at the very bottom, and this is true for a lot of the namespaces in the wiki, you can see a small text excerpt showing you how to use it and also showing you what it will do. It writes out what it expects the behavior to be. In this case, love.graphics.rectangle with fill 2050 60 120 just means that it's going to draw a rectangle, a filled rectangle at position 2050 with a width and a height of 60 and 120. Now, if that felt like a lot, that's because we haven't really talked necessarily yet about a very important thing, which is the 2D coordinate system. So in 2D games, in order to draw anything onto the screen, and this is actually true independent of 2D games, this is anything that requires drawing onto the screen, your screen is effectively just a flat surface, but it can be thought of as a Cartesian sort of coordinate system, a quadrant, with an origin that starts at the top left of the screen, typically, and goes positive X to the right, positive Y to the bottom, and any sort of where in between is an XY pair. And if you've taken geometry, this probably feels very familiar to you. Love2D is no different. Anything that you want to draw onto the screen has an XY position, or should have an XY position. If you don't give it an XY position, it starts or it gives it a 0, 0 position by default. And you can see this illustrated by the fact that when we run our code so far, the hello world text gets drawn up at the top left of the screen, because we're not passing it in any sort of explicit position. It's just being given 0, 0 by default as a result, and everything is relative to its top left corner. So it draws it going down to the right from the top left corner. Now, if we wanted to draw a rectangle, we would have to do the same thing. We would have to give it an XY position and additionally a width and a height in order for it to draw that rectangle. So if I go over to love.graphics.rectangle here in my code and I say, just by default, for example, let's say we're going to make it a fill rectangle at 0, 0, and I want to make it 20 by 20. So it's going to be a square in this case, and I rerun the code. We see a white box drawn at the top left of the screen, and this is 20 by 20 virtual, or 20 by 20 virtual pixels in size. And it's being mapped to obviously more than that in the 1280 by 720 window, but if you're taking the 384 by 216 virtual resolution we're drawing to into consideration, this is a 20 by 20 pixel rectangle. If I set this to be 100 by 20, you can see the same thing. Now it's a rectangle. It's 100 pixels wide by 20 pixels tall, but it's still being drawn at the top left of the screen because it's being drawn. Remember, the origin is at the top left, 0, 0. If I wanted to, for example, draw this a little bit further down, I can change this Y parameter to be, let's say, 60. And now it's being drawn down starting at 60, 0, 60, XY, 0, 60. and then it's still being drawn that 100 by 20 pixels. And if I set the X to be, let's say 60 as well, it's being drawn down 60 by 60 pixels towards the center of the screen, because it's going towards the right. Remember, positive direction on the X-axis is to the right, positive direction on the Y-axis is down below. And if we were to draw in the negative direction, for example, if I were to draw, let's say, if I were to draw this at -60, won't even see it because it's actually being drawn outside the bounds of the plane. So we're not limited strictly to the positive X and Y values for when we draw things. We can draw things off screen technically. So the viewport is effectively one quadrant, but it exists in multiple quadrants, if that makes sense. Just looking at the course or the questions, I haven't been paying super close attention for the last few minutes, but let me just make sure. Cool. Some people are saying they're having success running things, so that's great. Oh, if you're seeing a balloon flying without a game, then that means that you're running Love without actually running a program. So you're running Love by itself. It hasn't found a main.lua to start off. So do just make sure you're running your game project within Love 2D. So you're loading it in either by clicking and dragging it into the Love executable, or you are using the VS Code extension that we've talked about so far, and the shortcut, if that works on your system. So knowing that we have the ability to draw rectangles here, I'm going to now do something to get us closer to the vision of having a Pong sort of set up with paddles. I don't want to be hard coding typically the rectangles where I want them to be drawn. I want to draw a paddle. I want to think in terms of what's on the screen, in terms of the objects that are being moved around and manipulated. So what I want to do is I want to basically say player 1 is equal to curly brackets. The curly brackets are how you say I want what's called a table in Lua. And the table is a composite data structure. Basically, it allows us to put a bunch of variables, a bunch of pieces of data into one variable called player 1 in this case. So I want to say player 1 is equal to a table that contains X, which is going to be equal to, let's say, 10, and Y, which is equal to, let's say, 10 as well. And essentially what this means is that I have a player 1, a player 1 object, which contains its own coordinate, its own position in the game world. And this is typically how you would set things in a game engine or a game. You would have all of your objects, all of your characters and enemies and objects all have their own XY positions so that they can be drawn and changed and moved around, and they all sort of maintain their reference themselves. Additionally, I have the position, but I also want to be able to see, for example, I want to be able to draw or to know its size, right? So I'm going to go ahead and I'm going to say paddle width is equal to 10, and paddle height is equal to, or I should say, let's set paddle width to 8 and paddle width equal to 32. I think this is what I used in the original distro that I pushed. These don't need to be stored in player 1 necessarily, because the paddle width and the paddle height are going to be consistent throughout the entire game. These can be assigned essentially constant values. That's what these capitalized variables mean versus this non-capitalized player 1. If in case you were wondering why we have capitalized and underscore separated variables and then variables that are not. Typically that's the convention. Something that's constant, that'll never change, you want to assign it to a capitalized and underscore separated variable. It's just good practice in that case. And so you can probably guess where I'm going with this. Instead of having a rectangle that takes in these constant values, I can now say fill is still going to be the fill mode, but I can say, instead of I want it to be X value, 60 or -60, I can say player1.x. I can say player1.y. I can say paddle width, and I can say paddle height, save it, and then reload. And now indeed, you can see on the left side of the screen, we have a paddle drawn there at the top left, which looks very similar to what you might have seen in the screenshot in the slides. But all it is effectively is just a few simple variables in a composite data structure, a table called player1 that we're feeding now into this love.graphics.rectangle function call, which is just a very simple function that's purpose is only to draw a rectangle onto the screen, and by default, a white rectangle. So just looking at the screen. Are you a gamer? What's your favorite game? I'm very much a gamer. I like a lot of games. I like Path of Exile. It's probably a game that I play a lot of, and been playing Final Fantasy 14 recently, but I've played, I don't even know how many thousands of games at this point, so it changes on a daily basis. Yeah, if anybody wants to add their favorites in the chat too, Call of Duty, and so on, some people are saying. Yeah, games are fun. It's not all just about making games. It is about playing games too. You gotta appreciate. Somebody that I chatted with before, who I learned from in my early days, used to describe it as doing research. If you're a game developer, so it's good to do research. R&D is very important, and that means playing lots of games. So if you're trying to be a game developer, do spend a lot of time playing games as well. Ghost of Tsushima, CS:GO, RuneScape, Portal, Apex Legends. Wow, everybody, lots of preferences in here. Minecraft, I love Minecraft. Minecraft's great. All these games are excellent, honestly. Valerie asks, why draw off screen? That's a great question. We talk about this a bit in when we talk about Mario. So when you have games that are, when you're dealing with worlds, when you're not dealing just with, for example, games that are static like Pong, where your world is just one screen view's worth of space, you're going to want to draw and store the positions of entities that are off screen. So in Mario, for example, your window, you're only looking at a particular chunk of the world. You know that you can walk to the right or to the left or go up or down and explore a lot more of the world, see enemies and items and locations that are off screen. And what's happening is that often that content is being drawn off screen, or at least being represented off screen. Now, those, if your engine's optimized, your game is optimized well enough, typically those things aren't actually drawn off screen, but they do have off screen or negative or positive beyond your viewport wise valued parameters, variables, positions, I should say. And so that's typically where that becomes relevant, is when your screen is not the entirety of your game. When your game goes beyond the edges of your screen, you want to be able to draw and or at least update and represent objects that are beyond the edges of the viewport. So hopefully that illustrates that. We talk about that in the GD50 when we get into Mario specifically a lot. So that might be that might help elucidate. CS:GO, Creeper World 3. I tried Creeper World. That was an interesting game. I didn't get into it yet too much, but I liked the fact that it was this, you're basically fighting a amorphous blob. Dota and League is good. Do I have any published games? I do not have any published games. I haven't spent enough time on an idea that I love enough to market. Yours is still running. Sophie says that they're still running old code. How do I update and run? Oh, do just make sure it's saved. Oh, so Control S to save your code, and then redrag it into Love, or hit the shortcut to rerun it. I might be. The chat is moving so fast at this point. I'm super behind. Left 4 Dead. People are saying I'm trying to get to the very bottom of it. Okay, creating an idea might be the hardest part. Yes, I have lots of ideas. The problem is I never spend enough time focused on actually implementing them and staying in love with the idea long enough to see it through. One of these days, maybe. Yeah, we'll see. Okay, Mary says, install and follow up everything with results so far. That's great. Awesome. Super happy to hear. All right. Well, I'm very happy everybody's being super involved in the chat here and offering up what they enjoy playing. Nice to see so much variety, especially. What I want to do now, I want to take a few minutes actually and allow everybody some time to do effectively the next piece of the puzzle, which you might expect, which is I want to draw this next paddle, and I want to draw it here at the bottom right of the screen, but I want all of you to do it. I want all of you to take a stab at it. And we're going to take about 5 to 10 minutes here to do it. In which case I'm going to take just a brief break as well, maybe drink some water or something. But I'll be back in 5 to 10 minutes if with the goal of let's just try to do effectively exactly what I did up here with this paddle, but do the equivalent and have the player 2 paddle drawn at the bottom right of the screen. So we'll take 5 to 10 minutes to do that, and I'll come back and I will also implement it with all of you. In the meantime, I'm just going to put up a slide here just to show that I will be right back, and I will be back in 5 to 10 minutes. So stay tuned and good luck, have fun. I've got all the faith in the world. You guys can do this. All right, we are back. So hopefully everybody was able to implement that without too many difficulties. Now, some people are having some trouble with the push, it looks like, and some people are still having some trouble running the code itself. Yeah, don't feel too pressured if you're having issues now to get things working. Certainly do feel free to come back or download the repo after the seminar, or spend some time debugging maybe after, or get in touch with people on Ed if you're still having some technical issues. I know this is certainly one of the more technical seminars to get up and running, just because of the nature of game development. It can be a little bit, it can involve a few pieces. So it's totally understandable if you're having trouble. But thanks so much to all of the mentors and folks that are chiming into the chat to help other people out. This is super helpful, helps me out a ton, and everyone else involved here. So thank you so much. We're going to spend a couple seconds here just kind of implementing what I described previously. So effectively, we're going to do the same thing that we did in order to, and again, to restate, the goal is to have a second paddle on the bottom right of the screen. So what we're going to do is define another variable, right, called player2 in this case, and we're just going to say x is going to be equal to, now I could say something like maybe 384, or whatever the difference of 384 minus I guess in this case paddle width and 10 would be, so 18. But what I'm going to do instead is I'm just going to say virtual width minus paddle width minus 10. Now what this is going to do is it's going to use the variables that we've already defined to help us calibrate or calculate that that difference. Same thing for the y. We're going to say y is going to be equal to virtual height minus paddle height minus 10. And then down here, now we've defined what player 2 is. We're going to do the same thing in terms of how to draw it that we did for player 1, which is we're going to do another love.graphics.rectangle call, where we're going to say player2.x, player2.y, and we can again use paddle width and paddle height, save it, rerun it, and you'll see that we do indeed have a second paddle at the bottom right of the screen. Now, those aren't really super exciting in as far as they don't do anything. They're just literally rectangles that we're drawing onto the screen. We might as well just be creating art at this point. Very crude, simple, bad art. But the point is that we are taking our data and essentially taking care of the render phase of our game loop, and actually moving everything is when we get into the input and the update processing phases of our game loop. So I'm going to go ahead and close this out. Now, one thing that you might have noticed, which is kind of an annoyance, every time that we run the game, in order to close this window, I can't press a key to quit it. I had to actually go up here, click this box, click this X, or if you're on a Mac, it'll be a different button. I would rather be able to just use a key press in order to do this. Now, the wonderful thing is we have this love.keypressed function that we used previously. But what we're going to do is we're going to actually use it to take care of that problem of not being able to close the window with a key press. We're going to say if key is equal to escape. I'm just using escape as a default. You can certainly set it to whatever you'd like. Then, and then I'm going to say end. And then within this if then end block, I'm going to say love.event.quit. And what this does is, sorry, I just got a message from somebody. If what this does effectively is we have this love.keypressed function. It takes in a key. This gets taken care of by love2d, by the framework, by the program. Key is going to be anytime we press anything in love2d, it's going to send a message to love2d, and it's going to say, hey, a key was pressed and it has this code. And it's going to call this function every time that happens. So basically what we can say is if key is equal to escape, since we'll have a reference to key in the event that they press any key, if it's the case that they press the escape key, I want to do something in the love.event box of Legos namespace called quit, love.event.quit. And you'll notice that in Lua, just as a syntax aside, first off, you don't have to put your if conditions in parentheses if you're coming from C. This is similar to Python. And you don't have curly brackets. You have then and end, which are the equivalent of your curly brackets. So if needs to have a then and it needs to have an end. But this probably looks very similar if you've coded in other languages. Just the double equals, checking for equality. You have the key and then the string escape. So if we save this and then run it, and then I hit escape, I don't have to click the red X anymore. I can just hit escape. So this saves us a lot of work, and it also helps us get familiar with the idea of using user input, processing user input dynamically. So there's that. Now that takes care of the input side of things very briefly. Let me just go ahead and make sure I'm looking at the chat here. Didn't miss anything super important. Some people are saying the code being pasted in the chat from other people is bugged, which is a tragedy. I'm sorry to hear that. All right, doesn't look like it so far. It's a little bit tough to keep up just because there's a lot of messages, but I will do my best to peek occasionally. But that takes care of the input processing at a basic level. We're going to get into a couple of other things with input processing here in just a second. I would like to get into the idea of moving the paddles. But one thing that I want to also do before I do that is I don't really like the harshness of this black background. It's a little bit too dark, a little bit too harsh. So we're going to use a function called love.graphics.clear. And what this is going to do is it's going to let us clear the screen with a color. And a clear just means to wipe the screen effectively, but replace it with purely just one color. And to do this, I'm going to cheat for just a second and see. I don't remember the color offhand what it was, but it's down here somewhere. Right here. Here we go. We'll pretend that we didn't see that. I don't want to spoil too much. But love.graphics.clear takes in 4 color components effectively. You can ignore this /255 for just a second, but in the world of basically monitors in general, you have the idea of RGB, and that's red, green, blue. And if you've taken CS50 or looked at any CS50, or even if you've done anything related to, say, CSS or used like Photoshop or other programs similar to that, you might be familiar with RGB or hash color values. And those are kind of related. Hash color values are effectively RGB triples put into one string. But in this case, we're separating the components of RGB and this last alpha component, and we're passing it into this function. Now, the way that light works is that you can mix red, green, and blue light in a particular way in certain intensities, and you can get different colors as a result of it. The more color typically that you have, the brighter or stronger a color is. And as an example, 0, 0, 0, 0, if your RGB values go from, say, 0 to 255, which are 8-bit values, if you assume that, let's say you have 0, 0, 0 RGB, that's just black. There's no color at all. But if you have 255, 255, 255, all basically color value for all your components, that's white. It's pure white. All of the colors mixed together at all intensities gives you white light, and no color and no intensity just gives you nothing, gives you black light, quote unquote, the absence of light. In this case, love.graphics.clear expects a set of those components, but it expects them to be from 0 to 1, effectively, floating point values from 0 to 1. And this has to do just with the way OpenGL, which is the graphics backend of Love2D, works behind the scenes. It expects 0 to 1 floating point values, and then it converts that into sort of the RGB values. And in order to get RGB values, I was having to write sort of like, unintuitive, like 0.17, whatever values for all of these. We can instead, if we were to say no, the RGB triples that we want, we can divide those by 255, which again is the max value that those triples can have. And that will normalize those values to be between 0 and 1, because if it's 0 out of 255, it's 0. If it's 255 out of 255, it's 1. And if it's any value in between, it's going to be between 0 and 1, effectively. So that's how we can get love.graphics.clear to work. And if we save that and we run it, you may or may not be able to tell super easily on my screen, but certainly on yours, you'll be able to. This background is a little easier on the eyes. And this is actually closer to what the original Pong, if memory serves. I believe I took a screenshot of an old Pong game and color droplet color picker thing, grabbed the color off of it to see what it was, and then converted that into RGB, and then put that into love.graphics.clear. So that just makes it look a little bit nicer, at least in my opinion. But that's an example of how to use love.graphics.clear in the general sense. If you want to wipe your screen with a particular color, say maybe you have a game like Mario and you want to draw all the tiles and then in advance clear the screen with blue to be the sky, you can do that. And then we talk about that a little bit in Super Mario Brothers in GD50. So that's how we do that. Now I want to take some time now to talk about input, specifically how to get the paddles to move. And yeah, people are saying hex values. People are saying of the conversion between older versions and newer versions of Love. Yeah, that was one of the things we had to do when we updated some of the course content, was that they changed the prior version of Love did use RGB triplets and did sort of the conversion to OpenGL behind the scenes, and now it expects it just to already be the 0 to 1 value, so we have to do it ourselves. But it's not a huge deal. As long as you divide by 255, it's pretty straightforward. Now, in order to get the paddles to move, what we effectively need to do is we need to change these XY values. So they are just static right now. They're not changing at all. But if we were to change the XY values, it would lead to the paddles having the appearance of moving. And specifically in Pong, the paddles only ever move in the Y direction, up and down. They never move left to right. When we get to drawing the ball in just a little bit, the ball will be moving left to right and up and down and so forth. But the paddles will only get to move on one axis. And so we're going to show how to do that right here in love.keyPressed. So, or sorry, not love.keyPressed, in love.update. So the thing about love.keyPressed is that it is a function that executes one time when you initially press a key. It does not execute continuously. And the thing with the paddles moving is that they are continuous. They move continuously. So when I hold up or W or down or S, the paddle keeps moving or keeps moving up or keeps moving down. I don't press it once and over and over and over again to move it up, 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 and down, down, down. That would be a bad user experience. So what we're going to do is, first off, this gets into sort of the discussion of interpolated movement of delta time. And in order to basically get into that, we're going to define something called paddle speed. This is going to be the speed at which we want our paddle to move in pixels per second. So I'm going to say, let's just say 100, or let's say 140. Just some random arbitrary value. It doesn't have to be perfect. This is just a spitball. But earlier, I sort of mentioned this idea of delta time and the idea of moving something or updating something and interpolating it across different computers, different speeds of computers. And it's germane here because if I'm running Pong on a super slow machine versus a super fast machine, the paddles may move or skip frames depending, if in Pong, probably not as much, but if it was a more intensive game, the frames might drop in between, frame 1 and frame 4, for example. And so you're missing out on 2 frames of rendering or updating. And so you need to interpolate the difference between them in order to properly move the paddle that span of time, right? Because if I'm just moving the paddle each frame a specific set of time, but 2 frames drop, it's going to miss those 2 frames worth of movement. But if I multiply the speed at which I want something to move by the amount of time that's passed since that last frame that was calculated, which is what dt always is, delta time, meaning delta as in triangle difference of time between this frame and the last frame, it will accommodate or compensate for those missed frames if they exist and move it the same amount on 2 machines, even if one machine is super, one machine's smooth and one machine's super jagged. If it's moving them, if you're playing the two games simultaneously, they'll both still move the same, just one will look jagged because it's interpolating the movement every X frames, but it's still being calculated correctly. So we do this by effectively saying in love.update, first off, we need to decide whether we want to move the paddle. So I'm going to say if love.keyboard.isDown, which is a function in the love.keyboard namespace or puzzle box or a Lego box, which we haven't seen yet, but it's another thing that has a bunch of functions tied, of course, to the keyboard. If love.keyboard.isDown takes a string, and we'll say W for if you're assuming WASD movement for the left paddle, then we're going to say player1 dot y equals player1 dot y minus paddle speed times delta time. And then we're going to say else if love.keyboard is down for S, which is if we're doing WASD movement, that's going down. Player1 dot y is equal to player1 dot y plus paddle speed times the delta time. We're adding or subtracting from our own player y the paddle speed times delta time. And over the span of a second, this will add up to the entirety of paddle speed, meaning that we will move over 1 second's worth of time, 140 pixels of space. So if I save this and rerun it, and then I press W or S, you can see that the paddle is indeed moving, and I can actually move it above or below even the screen distance. Because remember, again, we can draw things off screen. So even if the Y position goes negative or past the bottom edge of the screen, it still exists in the world, but it's just not being drawn. It's not being rendered. It's not in the visible quadrant that we are looking at. Some people are saying lag. Hopefully it's not lagging too much for everybody. Screen is lagging, not lagging. Okay. Hopefully it's not lagging for people. I do apologize if it is. But if you run this and at least execute it on your machine, you see what I am referring to. And again, love.keyboard.isDown. We haven't looked at this else if, but it's effectively the same thing as in C or other languages. It'll basically check this if statement. Is this true? Is love.keyboard.isDown, meaning is it being pressed actively right now? And if so, do this bit of code. Else if, so if it's not the case that W is down, test this condition, if love.keyboard.isDown S, and then do the opposite, add to the Y value. So in other words, go down. Because remember, positive Y is down, negative Y is in the up direction. Why don't we take a few minutes again? I know it's been pretty brief, but just because this is a nice little chunk to bite off. Why don't we take a few minutes again to let people do the same thing, but do it for player 2. And in this case, player 2, at least in my mind, it should be using up and down, the up and down keys. So why don't we spend just a few minutes, not too long, but give it about 5 minutes, and people can take a stab at executing that bit of code. And then we'll see how people do with that. All right, coming back. So that one was kind of a straightforward one, so didn't allocate necessarily too much time for it. I did leave one thing unsaid purposefully, which was the key codes for up and down, which were, as probably some of you intuitively assumed, literally the words up and down. So we're going to go ahead and write that here real quick. So if love.keyboard.isDown up, then else if love.keyboard.isDown down, then end, we're going to say player2.y is equal to player2.y minus paddle speed times delta time. And then player2.y is equal to player2.y plus paddle speed times delta time. And if we save that and run it, and I move using up and down, I do indeed have the ability to move as a second player, and I can also move still with W and S. So things are moving, and effectively that's all of the, believe it or not, user input, at least for the paddles. There is a little bit more user input to be decided when we get into game state and serving the ball and that sort of thing, which hopefully we have enough time to get into all of the details on that. But that is the gist of the player input for the game. The Pong is extremely simple. There's not a whole lot to it besides moving a paddle and trying to avoid getting the enemy to shoot a ball past your left or right boundary. Some folks even mentioned, I think Johan mentioned clamping the value of the paddles Y such that it doesn't exceed the boundaries of the screen, which is excellent, and a higher level consideration that we talk about in GD50 when we get into Pong in that course. But for right now, we do still have the paddle within given the ability to move beyond the screen edges, and we probably won't spend time talking about clamping that here, but certainly something that you can decide to pursue on your own if you choose. Can we use equals, plus equals, star equals like in C? You can use equals equals. You cannot use plus equals, star equals, minus equals, and plus equals, unfortunately. That is a limitation of Lua that I am not a huge fan of, that I wish they allowed you to do. And same thing with plus plus and minus minus. But it's something that pretty quickly you I guess learn to live with. Given the rest of the language is pretty nice and simple and easy, it's not too much of a pain. But yeah, it can certainly be a sticking point, not a sticking point, but a minor annoyance coming from other languages with a better assignment composite assignment operators. Alto asks, are we going to go over how to write the AI code for this game? Not in this seminar. That is actually one of the challenges for folks that want to go beyond the scope of the seminar, is to write a simple AI. That's actually the first assignment for GD50 for Pong 2, is to write an AI for the paddle. And there are some interesting obstacles one might run into given a naive implementation of AI with Pong that are fun to explore, that folks tend to don't typically realize until they get into the actual implementation of it. And it can actually get pretty rich. You can actually get pretty sophisticated with it. But yeah, we will not spend too much time talking about that in this seminar. But that's an excellent question. Okay. So now we have input. We have the ability to move paddles up and down. Let's talk about the ball. We don't have a ball yet. We should have a ball to bounce back and forth. It's a kind of a main feature of the game. So why don't we do that? So we already know how to create sort of these tables, these data structures representing our paddles. We can do the same thing with a ball. So I'm just going to go ahead and create a new table called ball. I'm also going to create a new variable called ball size. And because a ball is uniform in its width and height, I'm just going to create one variable called size. We'll give it the value of 4 just by default. And then I'm going to go ahead in the balls table, and I'm going to say x is equal to virtual width divided by 2. So this is half of the screen. And remembering that things are drawn relative to their top left, I'm going to say virtual width divided by 2 minus ball size divided by 2. So that will effectively draw the ball, because the ball is 4 pixels wide. we draw it 2 pixels to the left of the middle, it will draw all 4 pixels such that they're perfectly centered in the middle of the screen. Same thing with the Y. We say virtual height divided by 2 minus ball size divided by 2. That will do the same thing, but with the height, with the Y position of the ball. So the last piece of this, as you might expect, we have to define the values, but we also have to draw them to the screen. So we can say love.graphics.rectangle fill takes in ball.x, ball.y, ball size, and ball size. Run this, and we do indeed see we have a ball there in the middle of the screen. So very lovely. Now, it's not very dynamic, unfortunately. It's just kind of static like everything else. And unlike the paddles, the ball actually doesn't move based on player input. It moves based on a set of conditions related to a very simple set of physics rules. In this case, it bounces off of surfaces and triggers I guess, a point to be given to your opponent, depending on whether it exceeds the left or the right boundary of the screen. Now, when we're talking about things moving sort of on their own in a game, we've already kind of indirectly talked about velocity in terms of Y velocity with the paddles, in that effectively their Y velocity is paddle speed when and if they are being moved by player input. But if things are being moved sort of on their own, they kind of need to contain their own velocity value. And the thing with a ball is that it can move in all kinds of directions. It doesn't move just in clean, X or Y directions, right? It can move diagonally, it can move all over the place. So we need a way in order to make this possible, in order to, one, make it move not consistent in the same direction, because that would be super boring if the ball always moved in one direction, one velocity every time you started the game. We need to make it move in a random direction. And to this end, we can use random number generation to do this effectively. So why don't we go ahead and do this? I'm going to, in ball, give it a couple of values, dx and dy. And these are going to be our velocity values. We're going to use these in the same way that we used paddle speed times delta time, but we're going to be moving velocity of dx and dy by delta time when we move the paddle. I'll move the ball, sorry, rather. The first thing that we need to do, though, before we get into that, is we need to actually do what's called seeding our random number generator. Because again, we're going to do this randomly. We're not going to give it a preset velocity value every single time. We're going to give it a random value on startup every single time. And to this end, we need to do what's called math.randomSeed, which is math is a Lua. It's built into Lua. It's a namespace in a similar sense to the love.x namespaces like love.keyboard, love.graphics, love.events. It's a namespace that's built into Lua. We're going to say math.randomSeed, and we're going to pass it a value called os.time parentheses. So it's calling a function called os.time, and os is another Lua specific library or a namespace that has OS related features. OS, short for operating system. In this case, getting the current time in milliseconds. So by getting the current time in milliseconds, which is always going to be a different value, and passing that into math.randomSeed, it gives our random number generator, which is what this random seed function does, a different initial value that it can use to generate new random values going forward. So what I can do is I can say, well, for example, if we go to, in this case, love.load to give it an initial velocity at the very beginning of loading up the game, we'll say ball.dx, which is our x velocity, delta x. If we say ball.dx is equal to math.random, which gives us a random number between 1 and whatever we decide to choose, math.random of, let's say, 60, and then ball.dy, math.random also of 60, What this is going to do is it's going to give us a random value assigned to dx and dy between 1 and 60, which means that it could be any diagonal vector up to a velocity of 60 pixels in that axis direction, x or y. Now, this doesn't do anything in and of itself because this isn't going to actually be moving. The ball's not actually going to be moving every frame. This is only a variable currently that our ball has in addition to x and y. So we actually have to do something with these dx and dy values. So we can do that in love.update, which is a perfect place. Remember, anytime something needs to be updated or changed based on time, this should go in love.update. So we'll just do that after all of our input is being checked for continuous input. We'll just say ball.x is equal to ball.x plus ball.dx times delta time. And ball.y is equal to ball.y plus ball.dy times delta time. Now, you might have realized already that this is always going to be a positive value, meaning this is always going to be a bottom right slanted vector of some slope, because these can only be positive values. In order to change this, we need to also have these be a 1 in 2 chance of being random, being negative. A random coin flip of it essentially being negative instead of positive. And this is extremely easy. All we need to do this is just say if math.random of 2 is equal to 1, then, so remember, math.random will go between 1 and 2, so it has a 50% chance of being 1. Then we're going to say ball.dx is equal to negative ball.dx. And the same thing here. If math.random of 2 is equal to 1, then ball.dy is equal to negative ball.dy. We can space those out. So we get an initial velocity, a positive velocity, and then we have a coin flip's chance to make it negative on the x direction, and then the same thing for the y direction. Save this. So this is being, remember, this x and y is now being updated in our update every time. So if you run the game, you can see that the ball is going up to the right that time, going up to the right, but a little different slope that time, down and to the right, very slowly this time. So this is important to observe here. We're going to fix this issue because nobody wants to play Pong when the ball's moving that slowly. So there's a way we can fix that. And notice also that even though it goes past the right edge of the screen, we're not taking that into consideration, we're not doing anything with that. So we need to do something with that as well. Run it a couple times to see if we can get a left direction. There we go, finally, going down and to the left. So it is random every time, and the slope of that trajectory is always random as well, or the speed rather. So we are moving the ball and it's random, but there are some limitations to it so far. Aditya is saying it's lagging. Hopefully it's not lagging. All right. Cool. So that is the gist of how we get the ball moving by itself. We have an initialization of its dx and dy randomly at startup. And we're going to need to do this multiple times going forward. Whenever the ball goes past an edge, it's going to need to be reset, reinitialized to some random velocity, right? So we're going to be reusing this. And then once we have it a velocity on the x and the y axes, we need to additionally use that velocity to update its x and y position. It has a position, but that's independent from the velocity. The velocity tells us how fast it's moving, but the x and the y position tells us where it is in space at any given point in time. So those are two separate but necessary and related sets of information. Okay. So now we have the data all set for movement of the ball. What we can do now is spend a second talking about game state, perhaps. I feel like that's important time to talk about it. right here. So game state is pretty essential in any game that's beyond drawing something to the screen. Your game isn't always in the same condition. You're not always doing the same thing. You're, for example, starting off in the main menu, going to maybe your load game screen, going into the game, going to a pause menu. Maybe there are different modes of game within the same screen, like in the play mode. Maybe you have a different interface or a different way of playing for engaging in combat versus exploring. And so state machines are essential in that they encompass this idea of being in a particular state at one given point in time and transitioning from that state to another state. So this is an illustration here of a game state for something like Mario as a character, not necessarily as a game state per se, but a character state. But the idea applies in the same way to game states. So you have a standing state. If you're Mario, if you press B, you go into a jumping state, right? Where you're then into like a sort of like in the air, right? And gravity's affecting you. And then you press down, you can go to a diving state. If you're in standing and you press down, you can go to a ducking state, and then you can release down to go back into standing. This is an idea in computer science, these sort of finite state machines that describe sort of like transformations from one state to another state to allow you to do all sorts of really cool things. But they apply to games because games are a perfect illustration of them, visually speaking. When you're in a main menu of a game, you're very clearly in a different state than when you're in a load game or in a play game state or the like. And for example, in Pong, if we go back a little bit, we can see that we have this title screen here which says press enter. And clearly the input criteria and conditions and behavior are going to change whether we're in this screen or whether in the actively playing screen, so on and so forth. For example, the ball's not moving here when we're just playing the game because it's waiting for us to press enter, such that when we press enter, it's waiting for the serve. And once we've served the ball and it's moving, then we're in the play state and we're moving the paddles and we're trying to score a point on our opponent. When a ball moves past the edges of the screen, we transition back into the serve state, only the score for player 1 or 2 has been incremented by 1. So now the game state in a different sense has changed. Now it's 1-0 or 2-0 or whatever the score is. And once we've gotten to 10 points or however many points is a requirement of your game, then you transition into sort of a game over state where the winner, and then you move on to restarting the game from the beginning where the score gets reset back to 0. So that is effectively encompassed with something like this. If you were to replace the standing, jumping, diving, ducking with main menu, serve, game over, so on and so forth. The same idea applies. And typically in Pong, at least, it's just waiting for us to press enter and for a point to get scored or for 10 points to get scored from one or the other player. But that is effectively game state in a nutshell. And we will need to talk about this very shortly here. The way that we're going to do that is very simply with just a variable, in this case, a string, and we're just going to call it game state. And I'm just going to create an initial state called title. And title is just going to be exactly how it sounds. We're going to display the title of the game onto the screen in the very much akin to that screenshot that I just showed you. And to do that, what we want to do first is create a larger font to display to the screen, because right now all we have is one font, which is just I think 14 or 16 by default. So to do that, we can very easily come up here to the top of our screen, sort of where we have all of our global information. I'm just going to come up here where we have all our constants, and I'm going to say large font is equal to love.graphics.new font of size 32, which is going to use the default font that Love ships with, which I believe is Arial. And then small font, it's going to be love.graphics.new font of size 16. And I'm not offhand, I don't recall if the default font size is 14 or 16. It might be 14, in which case this will be slightly larger than the font that we've already seen. And if you want to, you can also pass in your own font file as a parameter here. So if you had like myfont.ttf, you can actually sub your own font into here and load it at runtime, which is kind of cool. We're not going to spend time doing that, but we do that in GD50 if you're curious or have a font that you like in particular, you can absolutely do that. But we've got these font objects now that we can switch between when we draw text to the screen. So if I come down here to the bottom in love.draw, and then I say, after clear, if game state is equal to title, then what I want to do is I want to say love.graphics.set font. You have to actually set the font to what you want to draw to. In this case, large font. I'm going to say love.graphics.printf. This is a new function. We haven't actually seen printf yet. We've seen print. Printf is a function that actually lets us do some fancy stuff using centering and justification. In this case, we're going to use it to center our text, because if we were to calculate the centering of our text dynamically or explicitly, it'd be kind of a pain. But using printf, we can actually do this programmatically very easily. So what we'll do is we'll pass in our text. We'll say pre-50 pong. We're going to give it an initial x. So we're going to set it at 0, which might not sound intuitive if we're trying to center. Let's draw it 10 pixels below the top edge of the screen. We're going to pass in a column size. And this is why the 0 is important, because if we specify a column size, the next parameter in the function will use this column size to execute its behavior. So this column size, we're just going to use the entire screen. So we're just going to say virtual width. And within that column size, I want to center the text. So we're giving it the text, starting it at 0 of column size virtual width and y of 10. And within that column size, I want to center the text. And then I want to set the text, the font back to small font, so that if I call any text code later on, it's not drawing it in the large font by default. If I run this code, you can see that we do indeed have pre-50 pong drawn at the top of the screen in this new large font, and it's centered right in the middle of the screen too, which is super nice. I'm going to go ahead and look on the chat here, make sure I'm not missing anything. Games like PUBG will have various directions, and on 3D platform, which gets it in higher complex state. Yes, 3D games are extremely complicated relative to 2D games, especially implemented from scratch. Modern game engines like Unity sort of make the process a little bit less painful, but it can still be quite tricky. All right, awesome. Appreciate the positive feedback. Thank you guys very much. Yudi says math.random -300, 300. We absolutely could do that too. That's an excellent idea. Yudi Parshin, math.random -300 to 300. There have been instances where doing a math.random negative to positive, I may have conflated it with positive to negative. Ended up causing weird issues, but that would work just as well, doing a negative span of -300 to 300. But what we're going to end up doing in a little bit, actually, relative to germane to when we saw the ball moving really slowly in a particular direction, is creating a minimum starting point and then doing the conditional negativization, for lack of a better word, of that value, such that we always have at least a minimum absolute valued speed of, say, 30 or 40, so that we're never moving super slow. If you were to set it to math.random -300 or 300 to 300, you do have a possibility of getting a really slow value still. So that will not solve that particular problem. So we will need to do that, and we will do that actually in a short bit. Another thing that I'm going to do really quick related to the text, the title text, is that I'm going to say love.graphics.printf, press enter. And again, we've switched to the small font here. So now we have the now we're going to be rendering smaller, which is more appropriate for something like a press enter message, at least in my opinion. This is of course an aesthetic choice. I'm going to say 0 virtual height minus 32 as a sort of arbitrary value below the screen, but bigger than the text size. And then we're going to center this as well. Rerun this. Bad argument, number expected got string. Oh, I forgot to put in the, what did I forget to put in? Number expected got string. Oh, the column size, right. Column size needs to be virtual width right here. There we go. Let's try that one more time. And now you can see we have the press enter text here at the bottom, kind of above the bottom edge, but perfectly centered in the smaller font. So this is, taking these primitives, you can obviously go in a million directions and start to create simple UIs. There's a lot more involved in that, of course, and we talk about that in GD50, but this allows you to at least draw text anywhere on the screen. You can center it, you can right justify things as well. If you replace this with right, this should right align the text, as you can see. So you can set things to be however you want aesthetically. I prefer, at least for this example, to center everything. So we're going to keep it centered like that. And then that essentially completes the display for the game state. Now, the problem is in the title screen, like we said before, the ball shouldn't be moving. The ball should be static until we press enter, and then the ball should start moving. So we can take care of that by the love.update function encapsulating that logic. So here we can essentially just conditionally move the ball based on its delta x and delta y by saying if game state is equal to play, then do these two things and end, right? So now when I start the game, the ball stays perfectly in the center because the game state's not play, the game state is title, right? Because we set title right up here at the beginning. Now, in order to change the game state to play, that's an exercise for all of you, actually, for the next 5 minutes, 5 to 10 minutes. So knowing the game state and knowing that we need to press enter to change the game state, right? As an exercise, write some code that does that. And I will be back, and specifically make sure it changes to play so the ball starts moving. And I'll be back in 5-ish minutes to discuss it. Good luck, have fun. All right, so that one was pretty straightforward, probably. But again, a lot of these things, diving into a brand new framework, a new way of programming like Love2D, sometimes a big part of the struggle can just be knowing where things need to go, where things are, remembering how to alter certain behavior. Even something that seems as straightforward as just checking for a key press, just knowing where to go, which the syntax for it, especially if you're new to programming, it can be a lot. So yeah, some of this stuff can be deceptively straightforward. But yeah, some people posted in the chat correctly. It is indeed if key is equal to enter. In this case, if you're on a Mac, this is going to vary a little bit. If key is equal to enter or key is equal to return, then we're going to set game state equal to play. Oops. Specifically the string play. And if I run this and I press enter, you do see that not only does the text disappear, because remember the displaying of the text, the pre-50 and the press enter was conditional depending on the game state, but the ball also began to move because now the condition that we put in our love.update is true that game state is equal to play. So that is indeed now currently working. I'm a little blurry. I'm gonna do a little force thing there. Oh, nope, that didn't work. That work? Nope. That would have been worse. Oh man. All right, let's try that. That work? There we go. All right. Magic. We're going to now talk about the ball bouncing off of stuff. Because currently, when we let the ball just go and run wild, it just goes forever. It doesn't collide with anything, and we don't really see it for very long. However, in Pong, the behavior is such that the ball moves up and down, bounces off the top and bottom walls. And if it hits the left or the right edges of the screen, a point is given to the opposite player of that edge. So a couple of things need to be done in order to execute all of this properly. What we need to do is add, first of all, a score value to the player one object. And in the distro, this is actually done in separate variables, but it belongs probably within the player one and player two objects. So we're just going to say score is equal to 0 in player one. And then score is going to be equal to 0 in player two as well. They both have their own score value in their table, so that they maintain their own score reference. And real quick, what we can do is we can start drawing the score to the screen, which we're not doing yet. And to do this can happen at any time. This doesn't need to be just in a particular game state. We can always draw the score onto the screen. So we are going to make sure we set the font to large font. Love.graphics.print, just a regular print, and we're just going to spitball this a little bit, and we're going to do player one.score. We're going to do this at virtual width divided by 2 minus, let's say, 32, and then we're going to set this to be at virtual height divided by 2, and then we're going to do the same thing with the player two.score. Only we're going to do virtual width divided by 2 plus 16. I think this is right. I might have to tweak this a little bit. Virtual height divided by 2, and let's say minus 16. So it's a little bit closer to centered. And then let's set the font back to small font. Run this. Let's see what that looks like. It could be a little bit to the left. This one. Try moving that to 36. That's good enough. So it's roughly centered. To my eye, it looks centered enough, and that's effectively what the what Pong shows you. During the game, you have your scores right in the center, so you never really ask for where the scores are. And if I press enter, you can see the scores stay there in the center forever. So they'll always be visible, so we know who's currently winning, or who's tied, or whatnot. So that's taken care of. and it's dynamic such that we can tweak those scores depending on whether the ball goes left or right, and those values in the center will update, which is nice, which is convenient. Oh, Weffy, regarding return, that's to do more with Macs. I believe on Mac, if you were to say key equals enter, it doesn't work, or at least it didn't used to work unless Love updated it for Mac. But this, I remember specifically having to include this back when I developed on a Mac. Key is equal to return, because I think that's the default code for Mac's return key. But this was back in the 10.3 era of Love. They may have added return support or enter support rather in Mac in the more recent versions. Okay, so game state is equal to play. The ball moves. It does not bounce off of anything. And by the way, we're at 100 lines of code so far, so we've written a good amount of code thus far, but we still have a bit of a ways to go yet. Thankfully, we're making headway though. What we want to do is I want to take this code here, this ball velocity initialization stuff. I want to set that. I want to create a function for that, because I'm going to be reusing that once we go into the serve state every time. So what I'm going to do is I'm going to assume that I have a function called reset ball. I'm going to come down here, way at the bottom, and I'm going to say function reset ball, just like I would define sort of any of the other Love functions, except this is our own function that's not specific to Love. This is our own function that is completely our own, just whatever we decide we want to put in here. I'm just going to put all that in there, the exact stuff that we had before, such that it's the equivalent of basically just having copied and pasted this up there before. But since we're using it more than once we're going to be resetting the ball when we go into the serve state, or from the game over into the play state, or into the title state again, we're going to want to reuse this. And actually, while we're here, let's go ahead and make sure that we give ourselves a minimum amount of velocity. By doing this, by adding essentially a flat, basically however much you want, but we're going to say 30. Actually, we're going to say 60. It'll always start at 60 and then get a random value between 1 and 60 added to it, and then that will get flipped to random. And then the same thing here. We're going to say, except instead of 60, I'm going to say 30, because we don't need it to be quite as intense on the y-axis as we do on the x-axis. So we're going to seed it with an initial 30, flat 30, such that it'll always be a minimum y velocity, but not always super, super crazy. I'm going to save that. And then I'm going to go to the update function. And actually, what we want to do is we want to be able to serve the ball. We want to be able to calculate scores based on whether it goes to the left or the right edge of the screen. And we want it to bounce off the top and the bottom of the screen. So the first thing that we can do is basically, let's do it if it goes past the left or the right edge first. That's relatively straightforward. So what we're going to say is, if the game state is equal to play, then we're going to move the ball, and then we're going to check to see where is its X position. If its X position is beyond the left side of the screen, in other words, less than or equal to 0, then that means that the ball has gone past the left edge, and player 2 should get a point, right? So we can say is, we'll say reset ball, because remember, we want the ball to go back to the center of the screen. Game state should be equal to serve, right? Because we want to be able to press enter and serve the ball. We're going to say player 2.score is equal to player 2.score plus 1. And then we're going to, is that all we need to do? Players 2.score is equal to player score at 1, reset the ball with a new velocity. Game state's going to be equal to serve now. I think that's all that we need to do. Oh, we didn't actually test to see if it's beyond the left edge of the screen. So if ball.x is less than or equal to 0, then we do all of this stuff. We don't just do it flat out every time we update. So if the ball.x is less than or equal to 0, reset the ball. So put it right in the center with a new velocity, a random velocity on the x and the y axis. Game state is equal to serve, which is not play. Player2.score is equal to player2.score plus 1. And serve is another state that we need to add, essentially. So what we can do is we can come down here to where we have this bit of logic for if game state is equal to title, and we'll say else if game state is equal to serve, we're essentially just going to copy this code from the bottom bit, but we're going to put it higher up. We're going to put it at 10 on the y-axis rather than all the way at the bottom of the screen. And then we're going to say press enter to serve, exclamation point. Right, so now we have this message showing us that we're in the serve state that differentiates itself from the title state. The only thing is we're not checking in the when we press enter whether we're in the title versus the serve state, and we need to differentiate the two of those. So what we can do is we can say, because we're waiting for enter, we can say if game state is equal to title, then game state is equal to serve, right? Else if game state is equal to serve, then we're going to set the game state equal to play. And assuming I have this correct, if we go ahead and do this, we run this, 75, oh, whoops, assign, not double equals, typo. I'm gonna press enter. It says press enter to serve now, right at the very top. Notice the ball's still not moving. If I press enter, the ball's gonna move, except we haven't tested for if it goes to the right edge of the screen yet. So why don't we do that as well in the update? So if ball.x is less than or equal to 0, we're gonna reset the ball. Else if ball.x is greater than or equal to virtual width minus ball size, because that'll be right when the ball hits the edge of the screen. Because remember, everything's relative to its top left corner. As a result of that, the ball's x won't be matching virtual width until it's all the way past the edge of the screen. We want it to basically trigger as soon as it touches the edge, which means right when it hits the right edge of the ball, which will be 4 pixels from its x position, technically. So if we just check to see if the ball.x is greater than or equal to virtual width minus the ball size, which is 4 pixels to the left of the edge, that'll be the equivalent of checking for that right edge touching the right edge of the screen. So then we can do the same thing here. We can reset the ball, game state is equal to serve, and then we can say player1.score is equal to player1.score plus 1, right? Run this, press enter, serve, and boom. Now, I noticed that reset ball looks like it doesn't actually put the ball in the center of the screen yet still. So we need to do that. The velocity got reset to 0 and it's not moving, right? Because it's in the serve state again. We're now, and also again, notice that, or not again, but notice that it now reflects the score being updated. Player 1 on the left side of the screen did get a point. So now it's 1 to 0. But we need to, in addition to that, in our reset ball function, we need to say, essentially where we initialize the ball here, we're going to take these two. We're going to say, get rid of these commas, and then the ball.x is equal to that virtual width divided by 2 minus ball size divided by 2, and ball.y is equal to virtual height divided by 2 minus ball size divided by 2. Now, if we run this again, now notice the fact that it's not bouncing off the bottom means that it took it a second to get to the right edge, even though it was off screen. It still did eventually reach virtual width minus ball size. But once it did, it put the ball in the center of the screen now. We're reinitializing x and y to be those beginning center coordinates, right? So now we can effectively, infinitely calculate left and right edges of the screen being touched and then add to the score. There are a couple of pieces still left to this puzzle, though. Primarily, bouncing off the bottom edges of the screen and bouncing off of the paddles. And the bouncing off the paddle may be the trickiest, even though it's not super difficult. That might be probably the trickiest piece thus far. But bouncing off of the bottom and the top edges is itself a a somewhat challenging, I would say, possibly piece, but not super challenging. But I actually want that to be an exercise. I'm gonna give like between 5 and 10 minutes, see if folks can figure out how can, when the ball hits the bottom or the top edge of the screen, how can we make it bounce off such that it keeps going in that direction, but instead of going up or down, it goes the opposite wide direction. That's the next exercise. And it'll probably be the last exercise, actually. But definitely more of a challenge than the exercises thus far, but I think doable given the pieces that we have talked about so far. So I'm going to spend a few minutes allowing everybody a chance to implement this challenge, and I'll be back to discuss the implementation. So good luck, have fun. All right, we are back. So sorry everybody for moving fast on the last little bit of code there. Definitely just trying to kind of make sure we get everything kind of talked about before we hit 12 o'clock, my time at least. But yeah, I do apologize. I did go a little bit too fast there. So I'll definitely keep that in mind going forward. Essentially, the summary of the changes that we had added prior to that did involve going from having just a play state and a title state to having a serve state as well, which was important because when we have the title state, essentially that's the beginning of the game. But when we have once we started playing the game, between each time somebody scores a point, we want to give a second to breathe, to allow the player to press enter in order to serve the ball on their terms. So we essentially have a sort of buffer period in between each point being scored, and that's the serve state. So it's waiting for enter to be pressed again, essentially. And to that end, we added this bit of code here in draw after the bit of code for title, which says if game state is equal to serve, then just press then draw the press enter to serve bit of text. And in addition to that, we added some logic in the key pressed function, which said if game state is equal to the title, then we want to transition to serve. And this is when they press enter or return, recall. And then else if, so if game state's not equal to title, but it is equal to serve, then we want to transition to play, right? And whenever we are in the play state, right here, we move the ball first, and notice that the ball is never moving. There's no update logic for when we're in the serve or the title state, but when we're in play, and it's the case that ball.x is less than or equal to 0, meaning that's the left side of the screen. We reset the ball, which recall we took that sort of initialization of the dx and the dy that we did before, and we put that into a function because now we call it in more than one spot. We call it here, and we also call it here, and we call it in the love.load now, because this is where it originally was. We took it out, replaced it with the reset ball function call here. We pasted it way down below here in reset ball. So this was all up there before, minus these two lines. These two lines are necessary because these actually set the X and the Y to the center of the screen. Remember, these are just basically what was in our, when we created our ball table at the very top, these were the X and Y values that we put in there. And then we also check to see if the ball.x is greater than or equal to virtual width minus the ball size, which is just the offset, because rectangles are drawn from their left side. If the ball, if we're checking the ball's x, if it's greater than the left edge or the right edge, then it'll wait for the whole ball to go all the way past the edge of the screen because the ball is relative to its leftmost side. So we basically check to see if ball.x is greater than or equal to virtual width -4 to compensate for the ball's width, essentially. And then if it's the case that it goes past either edge of the screen, both of these cases are the same, we set the game state to serve, and then player 2 or player 1's score gets incremented by 1 depending on whether it goes past the left edge or past the right edge. Hopefully that's an okay summary. I know that it's a lot of bits and pieces that we've added kind of all at once to bridge us towards the final steps of the game. But hopefully that recap is a little bit helpful. Love.graphics.circle. We could use love.graphics.circle. Certainly that's a possibility. I think at 4x4 pixels, I'm not sure how it would look, but yeah, that would take the center, as somebody else said, and not the edge, which is a little bit trickier in that case. But yeah, you could certainly do that. There are some cases where using circles makes more sense than rectangles for sure. Good point. And I'm glad that the recap helped a little bit. Apologies again for going too fast. I'll try to take these last couple of steps kind of slow. We're going to now recap over the process of getting the ball to bounce off the bottom and the top of the screen. So to do that, it's going to be included in the games, if the game state is equal to play logic in our update function, because this happens when the ball's moving, only when the ball's moving. We can do it or just below the ball.x and ball.y movement bit of code here before the checking for the left and the right edges. So to do this, what we essentially need to do is if the ball is interacting with, let's do the top edge first. If the ball is interacting with the top edge of the screen, that just means its y is equal to 0, because that's the top edge of the screen, right? So we can say if ball.y is less than or equal to 0, then what we want to do is effectively, to make the ball bounce, we want it to keep moving in the direction it's moving, but we just want it to, instead of going up, we want it to go down. So all we have to do is just say ball.dy is equal to negative ball.dy. Its velocity, its y velocity now just needs to be negative. If it was negative 60, that'll make it 60, right? And the same logic holds true if the ball.y is greater than or equal to virtual height, which is the bottom of the screen, minus ball size, right? Compensating for the fact that, remember, everything's relative to its top left corner. If we want to check for the bottom edge of the ball to hitting the bottom of the screen, we need to compensate for that distance between the top edge and the bottom of the ball, which is the ball size. And if that's the case, then we also set the ball dy equal to negative ball.dy. And you can actually put this on one line right here if you wanted to, a composite condition, two conditions to set the same thing. But this is just a little bit more readable since that'd be kind of a long line. And if we hit to run the game and then we start it off, the velocity wasn't quite high enough. Still not quite high enough. Oh, you saw it there for just a second. Let's see if we can get it. There we go. There we go. Now the ball's bouncing off the bottom and the top. All we're doing, we're just flipping the velocity, flipping the y velocity to be negative or positive, depending on whether it's already negative or positive. That's all that's involved, and making sure we're checking to see whether it touches the edges of the screen, either the top or the bottom. So that's basically the gist of the of flipping, bouncing it off the bottom and the top of the screen. What's a little bit more complicated is, and this is probably the last big chunk before we wrap, although we could probably get into talking about maybe making a score screen at the bottom if we have enough time. But we need to check for collision. We need to check to see that the specifically paddle collision with the ball. So going back to my slides somewhere. We have a slide here which kind of illustrates what this is. So there's this thing called AABB collision detection, which is axis aligned bounding boxes. And this only works if your boxes are axis aligned, meaning that they're perfectly orthogonal, such that you can run a very simple math formula to basically check to see if two boxes are overlapping or not. And to check to see if two boxes are overlapping or not, you essentially just say, is this box, for each of its edges, is it past the opposite edge of the other box? In the case of, for example, this, if we were to look at this box right here, the blue rectangle, the blue square rather, if its left edge is past the right edge of the green rectangle, right? These two are, in other words, they're completely separated going this way, right? This rectangle's left edge is past the right edge of this rectangle, then there's no possible way they overlap mathematically, physically. They can't be overlapping. You do the same thing for every other edge. The blue rectangle's top edge, is it below the green rectangle? The right edge, is it to the left of the green rectangle? The bottom edge, is it to the top of the green rectangle? If any of those are true, then we know for a fact that we do not have a collision. We return false. But if it's not the case that any of those are true, then we know we have a collision. Notice, for example, in this instance, it's not true. None of those scenarios are true. We do not have the rectangle to be on the edge of the other rectangle. In no instance, the left edge of the blue rectangle is not to the right of the right edge of the green rectangle, and so on and so forth for every other edge. They are mathematically overlapping. So this is the algorithm we use, or rather the set of conditions that we check to see whether the boxes are overlapping or not. And if they are overlapping, and we run this code for the paddle and the ball together as two rectangles, right? Then we bounce the ball. We bounce the ball off of the paddle's left or right edge, depending on whether it's the left or the right paddle, and we carry on with the game. So let's go ahead and just write this code out. And if you don't completely understand this code, don't worry about it too much. You might have to spend a little bit of time thinking about it, or visualizing it. I like to visualize it, the edges going past the other edges of the other rectangles, like the rectangles basically being spatially separated. That's kind of the best way to think about it. Because if they overlap, then in no instance are they separated. They are always, for all four of those edges, they are not separated. They do not satisfy that condition. I'm going to write a collides function, which takes in a ball and a paddle. And the goal of this function is to return true or false to see whether the ball and the paddle have collided, right? So what I'm going to do is I'm going to return from this function. Return basically lets us spit back out a value. I'm going to return. So first of all, the set of conditions is that the b dot, we'll use b as the default, ball dot y is greater than the paddle dot y plus paddle width, or paddle height, so rather, right? So this is visualizing whether the ball's top edge is greater than the paddle's bottom edge, because we're taking p dot y plus paddle height. So if the ball dot y is greater than the p dot y plus paddle height, then it's not a collision. They're separated. They're not colliding. Or b dot x is greater than p dot x plus paddle width. This is the same thing, but now we're checking to see if the ball's left edge is greater than the paddle's left edge plus its width, which means we're checking to see if it's past the right edge. So if the left edge of the ball is past the right edge of the paddle, they are completely spatially separated, right? Or now we check to see, we're checking to see the balls, we're checking to see the ball's y, its top, its left. We got to check its, we have to check to see now if the paddle's left edge is past the right edge of the ball. So we do the inverse of this with the paddle. So we say p dot y is greater than b dot y plus ball size. And again, if this doesn't make 100% sense, don't worry about it. You might have to spend a couple of times looking at it. Even I have to like read this when I write it out from scratch and think about it for a second. Just because math stuff, it can be kind of a lot. Or p dot x is greater than b dot x plus ball size. So that's checking to see if the paddle's left edge is greater than the ball's right edge, right? Now this is if it's not a collision, we need to return the inverse of this. So we're going to surround all of this with parentheses. And then we're going to return not that value. We're going to turn the negative Boolean form of that. So Boolean logic, true or false logic. We're basically saying, are any of the edges of either the ball or the paddle past the opposite edge of the ball or paddle? If they are, if any of the two rectangles are in any way separated left or right wise, we need to, that means that there's not a collision. So we return the opposite of that because we want our function to give us whether they do collide. So we're going to turn not that. So this is a Boolean operation on a set of conditions. And now that function, we can call that anywhere to check to see whether the ball and a paddle, so P being a paddle we pass in, whether it's player 1 or player 2, are overlapping each other. So if I come up here to where we have the logic for the remember the logic for the top and the bottom of the screen bouncing, right? We can do the same thing, but for the paddles. So we say if collides the ball and player 1, else if collides ball player 2, right? So if collides the ball and player 1, so if the ball and player 1 collide with one another, meaning that those 4 conditions are not true. So we have the which means that they are not the not, which is a true value. If it's true that they collide, then we want to bounce the ball. In the case of player 1, we want to bounce it to the right, right? So that player 1's on the left. So what we do is we say ball dot x is equal to player 1 dot x plus paddle width. We do this because movement gets calculated sort of like frame by frame, and things move in fractional amounts depending on delta time. So it's possible that the ball is actually further in than the right edge of the paddle. And we want to make sure that the ball gets reset back to the edge of the paddle so it doesn't trigger true for another collision on the next frame, right? Because if we don't compensate for the collision and separate the ball and the paddle, they're going to infinitely be collided forever. We don't want that to be the case. We want the ball to get back outside of the paddle when it collides with the paddle. And not only that, we also want to reset the. We want to flip the delta x, because remember we did that with the y when we bounced off the top and the bottom of the screen. We just set the dy to negative dy. We do the same thing for negative dx. It's going to bounce it from left to right, right? Instead of if it's going left, it's going to start going right. If it's going right, it's going to start going left. Same logic holds true for if it's with player 2. We want to say ball.x is equal to player 2.x minus the ball size, because remember the ball is relative to its left corner. So if we set ball.x equal to player 2.x, the ball is going to be inside of paddle 2. We don't want that. We want it to be to the left of the paddle 2 by just the amount that the ball's wide, right? And then just like with the other condition, with the other criteria there, we want to set the ball.dx to negative ball.dx. Now, if everything goes according to plan, and I didn't mess up the AABB formula, we can go ahead and run this. And indeed, we see that the ball is bouncing off of the paddles. Nice. I always get a little nervous whenever I write a bunch of math stuff like that I'm going to mess something up. But thankfully, I've written that set of conditions enough times to where I remember it. And oftentimes, if you're game programming, it's not crucial that you know these physics or mathematical formulas, because you can just use a library to do it most of the time. But if you're writing it from scratch, it can be kind of interesting intellectually to know how it works. I'm not the best mathematician, but occasionally when you need to know something or learn something, it can be helpful. All right. That was the left and the right edges. One thing that we do need to also probably look at before we finish is the score going to a max value and triggering a win condition, right? This is important. Somebody asked about the paddles going off the bottom and the top edges of the screen. We do cover that in GD50. We may or may not have enough time. We have about 15 minutes left. We'll see if we have enough time. I know Johan in the chat had posted his solution to that. So maybe if Johan wants to paste his using math.max and math.min, it's effectively just making sure your x and y value, or your y value don't go below 0 and above virtual height minus paddle width or paddle height. And that's effectively the logic behind clamping the paddles to the top and the bottom of the screen. But that is effectively how that works. Let's get into the score here really quick. So there's a last state that we need to check for, or that we need to yeah, write some code here for. That's going to be the win state. Else if game state is equal to, we'll call it win. It doesn't. You could call this game over, game end, what have you. We're gonna set the font to large font. This is down in our love.draw function where we have all of our drawing and printing to the screen stuff. So we're gonna say love.graphics.printf. We're going to, let's just say local winner is equal to player one dot score is greater than or equal to 10 and 1 or 2. Now this might not make a whole lot of sense. So in JavaScript and C and Java, you can do basically a shorthand of a if-else statement on one line. So you can say, for example, trying to think of something appropriate. I guess in this case, you could basically, so here we're basically saying if player one score is greater than or equal to 10, then winner is assigned the value of 1, else winner is assigned the value of 2. And in something like C, it would look something like player one dot score is greater than or equal to 10, question mark 1 colon 2. That's something that some folks in the chat might have seen before. This in Lua does not exist. The equivalent is this, and or replace the question mark and the colon. This has to do with the fact, the precedence of and or, and the fact that they return the values in their logical expressions rather than just true or false. So this is something that you can do in Lua. So that's effectively what we're doing here. We're saying if player one dot score is greater than or equal to 10, set it winner to 1, otherwise set it to 2. So that we can then do player dot dot winner dot dot wins. You haven't seen this dot dot yet. What this dot dot does is it allows you to add strings together. So normally you can't just add with a plus, like a string winner to another string. You have to use dot dot. It's called a string concatenation operator. Other languages, for example, PHP, work in a similar way where they have a specific operator for string concatenation. Other languages like Python and JavaScript let you just use plus signs, which is easier, frankly. But Lua likes to be unique, so it uses 2 dots. And then we're otherwise just going to do the same thing that we've done before by saying 0, 10, virtual width and center to center that text in the middle of the screen at starting at 0, 10 using a virtual width column size. Now we actually have to get to the win state in order to trigger this code. And in order to do that, we need to come up here to where we add scores here. And then basically say if player 2 dot score is greater than or equal to 10, then game state is equal to win end. This is another interesting thing you can do in Lua. You can have a one-liner just like this, just then and then end being on the same line. Because remember, these are the equivalent of curly brackets. So if player 2 dot score is greater than or equal to 10, game state equals win. Same thing here. If player 1 dot score is greater than or equal to 10, then game state equals win end. So that accomplishes the goal of getting to the win state. And then last piece, once we're in the win state, and in this case, just to test it out, let's set this to 3, not 10. Just because I want to test really quick and not get 10 whole points scored, however long that'll end up taking. The last thing we need to do is when we're in the win state, we want to be able to press enter to go back to the title state, which remember, that's the beginning of our whole state machine of states and transformations in our game, right? And also before I do that, let's add one last thing to the win thing here, just to make that clear. Let's love.graphics.set font to small font, love.graphics.printf, press enter to restart, 0, 10, virtual width, center. So now when we're in the win state, not only will it show us which player won, but it'll also tell us to press enter to restart. And then once we press enter to restart, which we're going to take care of in here, right? We're just going to add another else if. Remember, this is when they press enter, right? Else if game state is equal to win, then the game state should get set back to title. And then we're get back to next frame. If game state is equal to title and they press enter, then go to serve, and game state serve, go to play, so on and so forth. Also, one last thing that needs to happen when they go from win to title, the scores need to be reset. So player 1.score is equal to 0, player 2.score is equal to 0, right? That's simple. We're gonna run it. I'm gonna let them score 3 points. Should work. Oh, I forgot to set that press enter to restart text at the bottom of the screen, so it looks horrible. But you can see that it says press enter to restart. Player 2 wins. Actually, that should be the opposite. Player 1 should have won, right? Yeah, because player 1, I've got something flipped there. It should be player 1 wins because the left side of the score, yeah, that should be it should be the case that player 1 wins there. But the point is, once somebody reaches 3 points, you win. Press enter to go back to the title. There's the title. The scores are 0, and the paddles are still in the same spot, which is fine. But the scores have been reset, and now we can just play the game again, just like we did before. Curious about that. Player 1 winning. Player 2 wins. Did I set the scores in the wrong spot? Where are the scores being drawn? Right here, right? Player 1 score. Oh, player 2 score. Yeah, it's a bit weird. Clearly having a brain fart or something akin to that. But I've mixed up something somewhere, and we only have about 5 minutes left, so I'm not going to spend too much time probably figuring out where that is. I will at least minimally set this to be press enter to restart. I'm going to set this to virtual height -32, just so that message isn't overlapping. But that, leave it as an exercise to the viewer to figure out where I flipped those two, where I flipped the, unless I flip this, unless that's causing the problem. But in any case, that is how you code Pong in a very simple way, minus that last little hiccup there. So I'm going to look at the chat, and just to make sure that I'm not missing anything here, but that's all the pieces, more or less. Now let's go back to the slides though for a second, because there are some additional things that folks might want to consider doing while we have a few minutes. So basic AI being probably the most straightforward recommendation as the homework assignment in GD50, which we say, okay, make the right hand or whichever AI, make it an AI-based paddle rather than an input-based paddle. And there are multiple ways that you could approach this, and multiple competent and less competent versions of doing this, and some that are just impossible to beat. But it's a good way to get your hands dirty with a little bit of sort of basic AI programming, so that your games don't require 2 humans. Another thing that you can get into, image-based paddles. So love.graphics.draw and using artwork, which if you take GD50, you'll know how to do that by the second week. Using audio, we didn't really get into audio and sound effects. Those are something that I like a lot. And you can use love.audio.newSource to create a new sound object that you can play, whether it's a music track or a sound effect. Sprite-based backgrounds. So if you wanted to change the background to be from a flat color to some sort of arena, that's an image. Multiple balls, all of which are updating and can trigger a point. Paddles that just in size, we cover that a little bit in breakout in GD50. And then a couple of things. So choosing before the game starts what your goal for points should be, having an input, being able to go press up and down to choose the amount of points you want to work towards. And then lastly, and this is a more technical detail that you might run into as you work on the AI, especially, our collision detection doesn't interpolate past a certain X velocity. So if the ball is moving super fast on the X direction, or even Y direction, fast enough, it actually clip through the paddle and completely miss collision detection. And there's a way that you can prevent that from happening by essentially interpolating the width of the balls, the width of the ball throughout the that entire delta between one frame and the next by checking each position to see if it interacted with the paddle in that span of time. And that is a little bit more sophisticated, definitely beyond the scope of even GD50. But that was pre-CS50, pre-CS50 games edition. I will look at the chat here for a little bit and see if there's any questions that are germane. Let me just reiterate that the code is here. So this is the full code that I did in advance of the lecture, of the seminar rather. That has all of the code in a slightly more robust version than what I did here. More or less equivalent. It's got 50 more lines, but it's effectively the same game. The code that we wrote up till now, I will commit and push that as well following the seminar. So if you want to see the code that we wrote today and maybe compare how that compares to the code that I wrote in advance, definitely feel free to do that. Let me just make sure I'm catching up here with all of the comments. I want to thank everybody for coming and for being as participative of you as you all have been. It's been a pleasure having all of you. And I apologize again for going a little bit too fast there in the center. I'll definitely keep that in mind for the next seminar. I do appreciate the feedback. To that end, actually, there is a URL. If you could go to cs50.ly/feedback, I think that is yeah, it shouldn't matter that doesn't have whether it's specifically for this seminar. I think once you go there, you'll see what you need to see to provide feedback. But yeah, if you could definitely provide feedback, be much appreciated. Definitely helps us improve as an organization always. And I personally like hearing feedback, so I appreciate it. Whether constructive, whether positive or negative, it's all towards a good end of improvement, generally speaking. So Aditya, the code that I just sent you has all of the code, the entire project, and then I'll be updating the code in a subfolder therein. It'll be pre and live. The live folder will have all the code that we've written up so far. So check on that in like 10, 15 minutes, and that'll have all of the code that we wrote together today. Maria, thank you very much for the kind feedback. I appreciate it. Oded says you messed up on the ternary expression. Line has to be 3 instead of 10. 3 instead of 10. Oh yeah, that's true. Yeah, good point. Good point. Might be able to resolve that right here, actually. Let's see, where is that? Yeah, right here, 3. Good catch. That should fix the issue of the player 2 or player 1 being the wrong winning character or winning player. So appreciate everybody who's posting positive feedback. Is the main.lua title a requirement for all games? Yes, in Love 2D, it is a requirement. It is a requirement. Awesome. Shit. And yeah, everyone's saying thank you. It's been my pleasure. I enjoy doing these types of things. So thanks for coming. Thanks for making it possible. A lot of you guys came. Appreciate that a lot. Love.window.set title to change the window title. True. That's actually in the pre-distribution, the pre-folder there. I did include that in there. So good point. Looking forward to using Love. Yeah, it's a great framework for 2D stuff. I'm a huge fan of it. Great for prototyping and even shipping something. Unity's got good 2D support these days, so might use that for depending on the sophistication. But I just think this is not easy to manage. So great job despite the hurry. Yeah, I think I might have got a little ahead of myself too much at a couple spots, but it felt like we caught up. Felt like we worked. All right. Just want to make sure I read everything here before we wrap up. There's a lot of great comments here. Can I recommend any books? None recent. There's a lot of books, like so many books that I've read and dabbled and collected over the years, but the most that I've learned has generally been just from making stuff and trying to learn stuff and reading other people's code than it has through books. Nothing offhand. And Unity is such a big platform now, and I haven't seen any tremendously useful and thorough Unity books, but I'll try to keep on top of maybe the landscape in that regard to see if there's anything new. I haven't checked in a while. Is the course done the same way as today's seminar? Not exactly. It's a bit more traditional lecture-wise in that we do it in front of a lecture hall. The videos are all on YouTube. You can check them out. If someone has a link to that, they're all on YouTube already from 2 years ago, 3 years ago, actually. But all the information is still the same. We've made a couple of minor changes. Seminar's been so great. Can't wait for the next set. Appreciate it. Thank you very much. We're just skimming through the chat here. Does Love2D support hardware acceleration? I think by default it's hardware accelerated because it runs through OpenGL. So it should already be hardware accelerated. Would I prefer for coding games, Pygame, Love2D, or another one? Love2D over Pygame probably, but I haven't used a ton of. I've only used Pygame a couple times, a long time ago. I'm more of a fan of Love2D, but more of a fan of Python, the language. So it's kind of a mixed bag there. But the two are relatively comparable, I think. Do I like Unreal Engine? Yeah, I do like Unreal Engine. It's a bit more hard to get into. It's very technically, very impressive technically, but it's not the easiest to jump into relative to like something like Unity, which is built, I think, a bit more for people that are newer to game development or trying to be more productive and not spend as much time on the visual side of things. And although Unity's added a lot in that regard to their rendering stuff. Do we discuss Unity and GD50? We do, yes. Basically, the games we produce here will be available for both Windows and Mac. Yes, you can run any of the games that you make using Love on any platform that supports Love. And you can actually bundle Love with a game. There's a way to do it on the wiki. It tells you about how to do it such that you can just execute it like it's an app, and that should work. It should work just like a native application. It'll feel like one, at least. Yeah, to the question that you asked, yeah, will it make it like an executable game? Yeah, effectively. Can Lua be used in the CS50 IDE? I'm not sure, actually. That'd be a question for David or Kareem. I'm not 100% sure. Lucas says you are cool, Colton. Thank you very much. I appreciate that. Thank you. That looks like most of the comments. I apologize if I missed your message. If you wrote something, I do apologize. I know that other folks in the production team are trying to wrap up, so we'll probably wrap here in just a second. What's a typical day as a game developer? Having not actually worked in a company firm producing commercial products, but only hearing about it, it seems like it's pretty stressful. I have a close friend who works in the industry who basically I've talked to other people that have worked in the industry, and it can be a lot, but I mean, I guess if you love it, it's probably fine. I know that there are some companies that have a reputation for overworking their staff, and that can be kind of an issue, I think. But it's a unique industry. I think it's cool. Do you play games from Steam? I have like 1,000 Steam games. Not even an exaggeration. For CS undergrad, do you have any advice to follow while entering the industry? If you're entering the game industry as a CS grad, I'd probably say study computer science over maybe something catered towards game development, because game development is just computer science used in a particular way. And if you decide to change industries and you don't like the games industry, a CS degree will take you further than a game certificate or something like that. That's at least my opinion. Different people will disagree on that. That's just my opinion. If you love what you do, you won't even feel you're working. That's why I'm gonna go for game development. Yep, true. Absolutely true. Do I like CSGO? I haven't played a lot of CSGO, but I did play a lot of Valorant, and I like Valorant, and I almost played CSGO. So I thought about getting into it, but I'm not currently in an FPS state of mind. So I haven't played in like 2 months or a month. Or like Siege. I haven't played Siege, but it looks fun. All right, I think Prod wants me to probably cut things short, but I appreciate all the feedback, all the participation. It's been lovely chatting with all of you and doing this Pong seminar. If you liked what you saw and you enjoyed this content, do check out GD50 on cs50.harvard.edu. There should be a link to it. Let's see, cs50.harvard.edu. Might be on a different place. The tracks page. I'm not sure where the tracks page is offhand, but CS50 tracks, probably could just Google that. CS50 tracks. Oh, that might not be considered tracks, because tracks are a part of CS50. Yeah, offhand, I don't know which website we're hosting the CS50 GD50 content on, but the GD50 stuff is online. It's on YouTube as well. Follow that. Do all the exercises in there. It's I think I set it up to be pretty fun, to have a lot of good sort of examples. But if you like what you saw, we go into a lot more detail, a lot more fun stuff there. But this was pre-50 CS50 Games edition. Thanks for participating. I'm going to sign off and wish all of you the very best. Good luck, have fun, play games, do lots of R&D. And I'll talk to you all hopefully at some point in the future. See ya.